Namashivaya, am I audible?
Yes, Hari, you are audible.
Thank you.
Hello, can you hear me?
Yes, sir, you're audible.
Okay. And can you see me also?
Yes, sir, video works as well.
Okay, now, can you please tell me how to share my PowerPoint presentation? Share screen, is it?
Yes, sir. Yes, sir.
Share screen. Share screen. Now?
Now,
It's somewhere I saw. Here.
Now you
Yeah.
no, share the screen. Then once you share the screen, here you can
The
This
screen
one.
is visible.
Go to video.
wait. Come to no, you see, just will you ask them whether they can hear you? And
Yeah,
see
now you can hear
properly?
and see me.
Yes, sir, you're audible and we can see you and the screen is visible. However, we request you to put it in presentation mode.
Yeah, we'll put.
Yeah.
That is. Okay. It's now in presentation mode.
Yes, sir, it is. Thank you.
Pointer. I need pointer. Here. Right click. Yeah. Okay.
So we request you to unshare the screen now. And once we start the symposium, yeah, thank you.
Okay.
Good morning, good afternoon, and good evening to one and all. Welcome to the second day of the International Symposium on Water Sustainability, IWSS 2022, organized by the Amrita's UNESCO Chair on Experiential Learning for Sustainable Innovation and Development and Amrita School for Sustainable Development. Today, the keynote talks during the first session will be chaired by Dr. Alka Singh. She currently serves as the Assistant Professor in the Amrita Center for Wireless Networks and Applications. She also served as a postdoc at NASA, the Jet Propulsion Lab, and the Goddard Space Flight Center for almost 4 years prior to joining Amrita Vidyapeetham. She received her PhD from the Technical University of Munich, Germany, and a master's in geoinformatics from ITC Netherlands. Her research interests are in hydrological mass variations, drought and flood, groundwater, forest fires, and water carbon cycle. Over to you, Dr. Alka.
Namah Shivaya, and a warm welcome to all of you. We have very interesting presentations today, and we are very much looking forward to it. We have first a presentation from Professor Keshava Rao Kaza. Professor Kaza, a very warm welcome to you. Professor Kaza is a retired professor from Chemical Engineering Department of Indian Institute of Bangalore. So he has obtained his PhD from PhD MS from University of Houston in 1982. He has a bachelor's from IIT Madras, and he is also a fellow from Indian Academy of Science. He's an expert in chemical engineering, chemical reaction engineering, treatment of drinking water, applied statistics, etc. Today, Professor Kaza is going to present on defluoridization of drinking water, which is such an interesting topic. We are very much looking forward to hear from you, sir. I'm handing over the floor to you.
Thank you, Dr. Alka, for the nice introduction. I thank the organizers for inviting me to give a talk. The material is a bit dated, but they felt that I could still present it. So let me start. Yeah, can you see my screen? Hello?
Yes, sir, it's visible.
Okay, so I'll speak about defluoridation of drinking water. This problem has been examined for several decades, but still the end is not in sight. As Piet Hein says, it hits back often. You will see in the talk. This is work done in collaboration with some students and some of my colleagues, and funding from the Department of Science and Technology. This is the outline of my talk. I will describe what fluorosis is, and then talk about defluoridation or removal of excess fluoride from water, then summarize what we have found. Fluorosis is a disease caused by the ingestion of excessive amounts of fluoride by people and animals. This has been known for a long time, and you may wonder where this fluoride is coming from. One source, which is minerals such as fluorapatite, where in the Earth's crust they leach into the groundwater, and many people, as you know, in India use groundwater for drinking. So if you go to deep borewells, you're likely to get fluoride contaminated water. Other sources, industrial effluents from semiconductor industries and so on. And the crops grown using this polluted water also contains high levels of fluoride, such as tea and vegetables, fish. Here are some of the minerals like fluorapatite and fluorite These are calcium compounds. There's also sodium compound. In India, the major sources of fluoride are water, food, and dental products, with the first accounting for about 60%, it's believed. In parts of China, high fluoride coal is burnt for cooking indoors, for drying food. And apparently this leads to a high concentration of fluoride, of course, not as F minus, but in some other form in the air and particulates. And this also causes fluorosis. The guideline value or the limit for fluoride in drinking water, throughout this talk, CF refers to concentration of fluoride, is 1.5 milligrams per liter, according to World Health Organization. And the Indian standards have a more stringent value of 1 milligram per liter, which is called acceptable, and 1.5 milligram per liter, which is permissible in the absence of an alternative source. So some relaxation is there. The reason for the WHO guideline value is that above this value, there is an increasing risk of dental fluorosis. But there are indications that even if the fluoride concentration is around 1 milligram per liter, depending on the diet, one may have fluorosis. So one should be tread carefully. The first symptom of fluorosis is called non-skeletal fluorosis, which is an early warning signal. Symptoms include gastrointestinal discomfort, weakness, depression, and so on. Then we have dental fluorosis, which is shown by these brown bands on the teeth, and the teeth get pitted and mottled. And then even worse, if you continue to drink the fluoride water, skeletal fluorosis, where the screen is, excuse me. Okay, let me skip. Where the hands and bones get deformed. In India and many of the neighboring countries such as China and Pakistan, the fluoride level there is in excess of the guideline value. In Australia too and parts of Africa. In 2014, it is believed that 12 million people in 19 states were affected by fluorosis. Newspapers continue to write about this problem, and this has spurred researchers to investigate ways to tackle this. You can see a person trying to walk with 2 sticks. The fluoride concentration at a few places is listed in the groundwater. You can see it is ranging from 3 to 24 in this list, in this table. The highest natural level is 2,800, which is much more. But even these amounts of the order of few milligrams per liter are enough to cause serious health problems. In India, it's estimated, of course, this is an old figure, that about 66 million Indians are at the risk of being affected by fluorosis. Later, somebody, Chakravarti and co-workers have given the same numbers, but they say they are suffering from fluorosis. I am inclined to believe the first statement. This statement by a villager affected by fluorosis provides powerful motivation to do something about the problem. She or he said, our shoulders, hips, and ankles are swollen all the time. If we squat on the floor, it's painful to stand up. So can we do something? Well, there's some ray of hope. One lady whose back had become bent because of fluorosis started drinking rainwater harvested from the roof. And in 6 to 7 months, there was no pain, though the posture had not improved. So that's one positive sign. So what I'm saying is the cannot cure the skeletal fluorosis, but at least the pain can be alleviated. Perhaps this defluoridation is an unending quest for solutions, like many other engineering problems. The first paper may be due to Borov in 1934. He suggested the use of alum, that is aluminum sulfate, sodium aluminate, ferric salts, etc. as precipitants, and zeolite, bauxite, silica gel, activated alumina as adsorbents. Um, so at the present, there are over 900 papers, and probably this number of 900 is underestimate, where people discuss methods of defluoridation. But at the same time, the population susceptible to fluorosis is increasing, and it's around 200 million. Perhaps these are like parallel lines which never meet. The reason is very few papers actually take the proposed solution all the way to the field level and test it for enough time. We also have not been successful in this regard. So I don't want to criticize anybody. I'm just telling this. Here's one contribution from India, from the National Environmental Engineering Research Institute, Nagpur, Nalgonda technique, popularized in the mid-1970s. And it involves the addition of alum and lime to water. The interesting range of time scales for dissolution, seconds, for formation of flocks, that is aluminum hydroxide is generated in situ and binds with the fluoride, that is in minutes, and sedimentation of flocks, hours. Now we have to filter the water, add bleaching powder for disinfection. So this was actually involves a complicated reaction, the kind shown here, where the main thing is this ALOH thrice, ALOH2F, which is the flock bound with the fluoride, and that's the one which settles down. The problem with this technique is that the dose of alum and lime depends on the alkalinity and the fluoride concentration. So you need an operator. If the fluoride concentration varies, you have to add different amounts. So you can't add same amount every time. And the high dose of alum, sometimes up to 1200 milligram per liter, may exceed the acceptable limits for sulfate, which is 200 milligram per liter, and aluminium, which is much lower, by 0.3 milligram per liter. There's a considerable amount of sludge generated, which is has to be disposed of. An assessment in 2004 said it has not achieved a great deal of success in the field, though many field level stations were set up, mainly because of the need for constant attention. Sorry, the screen keeps jumping for some reason. The Nalgonda technique I've already discussed. The cost is very low. That's the attractive feature, and simple equipment. The adsorption requires periodic regeneration because the adsorbent will get saturated with the fluoride after some time. The cost in 99 was stated to be of the order of 1 rupee a liter. Electrocoagulation, where aluminum hydroxide is generated in situ by using aluminum electrodes, it requires electricity. The cost is low, but once again, a lot of sludge is generated. So since this conference is on sustainability, we have to somehow make it a circular economy, and that is the difficult part in all these techniques. Reverse osmosis, another classic example, much favored by some of the governments, including one in our state of Karnataka. It requires electricity, and but the downside is produce water of good quality, and cost also is reasonable, 0.1 rupee a liter. But the reject stream, at least the plant we had visited, about 20 to 75% of the feed is rejected. Rainwater harvesting, there is no cost as per se, but you have to build a sump to collect all the rainwater. See, you have rains only for part of the year. So if you want to have a supply for most of the year, you have to build a big sump. That's the cost. And there's also contamination on the roof due to dirt and bird droppings and so on. Solar distillation is a simple technique. I'll say more about this, but the output may not suffice on cloudy days. So it won't work in areas where there's not much sunshine. Rainwater harvesting is very simple because you just have to collect the rainwater. So it is underrated by engineers. But in future, we may go in for this on a larger scale. It has to be, because it's stored in the sump and is collected from the roof, it may have bacterial contamination, as I mentioned. Here's an example where the fluoride concentration was well below the acceptable limit, but the concentration of E. coli, which is an indicator organism, is high. So we have to use some method of disinfection. So this is how this defluoridation problem always keeps hitting back. Some catch is there. Of course, somebody may come up with a brilliant idea, but we have to see. Here's another process where alum and lime extends the life of the bone char column. Bone char may not find favor with some sections of Indian population because of the use of bones. And the capacity of the fluoride treated one was not up to the mark, but still the government allowed it in the want of an alternative. Our present work deals with adsorption using activated alumina. I'll refer to this as AA, and then a hybrid anion exchange resin embedded with zirconia nanoparticles, HAIX, ZR. And some work on solar distillation and rainwater harvesting. Here is this blue shed here contains the reverse osmosis unit. The treated water is collected in this tank, and villagers are collecting it in these pots. This plant is at Yelampalli village, about 120 kilometers from Bangalore. The flip side is that the reject from this plant is let out into a pond via a pipe and a drain. So the reject water, which has high concentration of fluoride, again contaminates the water bodies. And you can see the reject stream has a much higher fluoride than the permeate stream because a large amount is rejected. This does not operate continuously because of erratic power supply in the village. You can see that the permeate, which is shown by these triangles, has very good water quality in terms of fluoride, which is 1 milligram per liter is the acceptable limit, and it is well below that. But the feed and reject, this is a feed. They have a very high concentration of fluoride. So here is our plant we decided to set up mainly at the instigation of my friend Professor Sen Gupta. The reject water comes from the right and then flows through a sand filter and then into the column packed with, initially we started with the activated alumina, the adsorbent, then it's pumped up to this tank, which contains the treated water, which flows down by gravity and is collected. See, the inlet concentration of fluoride on different days is the order of 3 to 4 milligrams per liter. And the outlet concentration is below detectable limit in the initial stages, when only about 2.6 bed volumes will be treated. But by the time we reach 50 bed volumes, already it is just near or a little higher than the permissible limit of 1.5 milligram per liter. So it's not going to be a viable process. Also, this is something we had not anticipated. There was corrosion at the wells of these columns, and water started leaking. So that's one thing we could not fix easily. The other problem was a completely different kind. That is because this was open and there are various the government school and offices, panchayat office nearby, and people move about here. Some of the pipe fittings were stolen, and so we had to build an enclosure to ensure the safety of this plant. Finally, when we decided to decommission it, we had to make sure that it was removed safely so that the overhead tank doesn't fall on some of the children playing nearby. So these are problems we didn't anticipate sitting in the office. So there, in this presentation, the 3 horizontal bars refer to the surface species. So here in the surface species, the neutral form of alumina is ALOH, not ALOH thrice as in solution. And the uh, cationic form is ALOH2 plus, the anionic form is ALO minus. The reactions with fluoride are shown here. Basically, they form ALF, and to regenerate the adsorbent, you have to use some alkali rinse. So there's some interesting reactions with carbonate. The reason for indicating this is that later we shall use some water containing carbonate. Now the carbonate forms in one of the reactions H plus, and H plus can react with ALOH to form ALOH2 plus, which may further bind the fluoride. Just please keep this in mind. Later we shall refer to it. This is a schematic of the the hybrid hybrid anion exchange resin prepared by Professor Arup's group. We have polystyrene cross-linked with divinyl benzene containing quaternary ammonium functional groups. And this is embedded with hydrous zirconia oxide nanoparticles in the range of maybe 3 to 30 nanometers. Now, the reason for this anion resin is shown here. In this resin, the R plus, the cation, is fixed, and the anion, say Cl minus, just for example, is mobile. So the Cl minus can be exchanged with any anion in the water, say B minus could be F minus, fluoride. But the
sorry to interrupt you, Professor Kasa. You have 5 more minutes, please.
Okay.
Can you try to step in?
Okay. Yeah. Okay, I'll just skip all this and show you the results with the, this is the RO reject column. The COI is the inlet and CEI is the exit. And you can see that the fluoride is removed up till about 200 bed volumes, but this adsorbent leaches nitrate because the manufacturer said nitric acid was used as a binder while preparing the adsorbent. The other ions are not removed much. The better designed adsorbent, the HAIX, unfortunately removes only about 50 bed volumes of fluoride. The cost comparison you can see here is in the range of 0.1 to 1 rupee per liter, which is very high for activated alumina, and 0.2 to 11.5 rupees per liter for HAIX. So both of these are not good for RO reject. I'll just show you one result with the inclined basin solar still designed based on design of Thomas. We have a basin with a bed of sand or activated carbon and water and a glass plate. Solar radiation passes through the plate, and the water evaporates and condenses on the inner surface of the plate. It is collected here. So this water, all the anions are well below the permissible limits, and it's good for drinking. But and if you use activated carbon instead of sand, even the objectionable odor disappears. All the cations also are in the ranges except ammonium, which is high. So let me summarize. Prolonged ingestion of water having fluoride greater than 1 milligram per liter leads to fluorosis. Dietary interventions can alleviate fluorosis to some extent. Reject water from a reverse osmosis unit at Yelampalli has high concentration of fluoride, nitrate, chloride, and sulfate, and about 60% of the feed is rejected. The AA, that is activated alumina, removes fluoride, but not the other anions. The other adsorbent, which is mechanically more robust, removes fluoride and nitrate to some extent, but unfortunately the cost in both these cases is high. So here, in this case, we have not been very successful. This water can be distilled using a solar still, But here the problem is the output is low. So you need a large area, especially when it's cloudy. And harvested rainwater is of good quality, but you need money to buy a good, build a big sump and also treat for bacterial contamination. So to summarize, let me end with a line from Bhajagovindam, modified slightly. It is hard to cross this ocean of fluorosis. Save me from it, merciful Lord. Thank you, and sorry if I exceeded the time.
Thank you very much, Professor Kaza. Not at all. You very much finished in your within the time assigned time. It was such an interesting topic. I mean, this considering the future drinking water crisis, upcoming drinking water crisis, and even ongoing for many places. This is very engrossing presentation, and it's very crucial topic that our groundwaters are contaminating at such a large scale. And we need to learn more about this from chemical engineers like you. How do we really treat them? And it was quite interesting to know that even RO water is not fluoride free. Is it right? Or I understood it the other way around?
The RO stream splits the feed water into permeate and reject. The permeate is essentially free of fluoride, but the reject has a high concentration of whatever was there in the feed get concentrated in the reject.
Okay, so at least if we use RO, then we can depend on it that there is no fluoride in it.
Yeah.
Okay, yeah, let's say at least something which is acceptable limit, within acceptable limit.
Right.
So I was wondering, is there any element which is like, we know this region is, if we say this region, groundwater is highly contaminated with fluoride, is there any kind of statistics or something we know that because it is fluoride prone or a contaminated region, it is more likely to have any other element or heavy metals or something like aluminium, or you were talking about different elements. So is there some statistics which says that because this region has more fluoride, most likely this region has so and so and so other elements also, possibly?
Actually, there are many papers on this kind of studies, but I'm personally not familiar with them. Studies at different parts of India and other parts of the world where the fluoride is high, what minerals they could be in the ground and so on.
In India, basically, the contamination is big because of the rocks we have.
Yeah. Right.
Unlike China, where it seems you said that they have coal which is contaminated, or why is it cooking?
Yeah, the coal seems to have high fluoride content. Like we have high sulfur in our coal, they have high fluoride.
So, which probably means the living organisms there had more fluoride, while could that mean that the limit, acceptable limit for that people living in that area would be higher than? I mean, when it is so integrated in their system since long that it is there in the coal or fossil fuels, I can assume that it's there in the generations living there as well. I mean, people may have different fluoride.
So what happens is, if
you know, the range to acceptable level.
Yeah, if you are constantly exposed to this fluoride, then the disease will set in. That's what that paper has said, which I referred to in China. Also, they have, that's why that whole region is marked with blue color in the map. There is excess fluoride. There are a lot of papers from China also trying to discuss this. So even though the coal has high fluoride, it doesn't mean we have become immune to the effects of the fluoride.
Okay. So which leads to more deformation there or no?
I don't know of comparative studies between India and China, but they have problems.
Mhm. Yeah, I mean, it's very interesting to see how water contamination is impacting and how it is varying over different geographical region, and are there different, I mean, like you talked about so many chemical reactions and how different ions and ions interact, but also it, like how human react to it is probably different from one region to another.
Right.
I was hoping for some questions, but it seems right now we don't have questions. So if you have, if any of the participant has questions, can you please write it in the question answer session? And Professor Kaza, could you please reply to it? Okay, thank you very much, Professor.
Thank you.
Thank you so much.
Thank you.
So next presentation is from Dr. Debapriya Datta. So Dr. Datta is currently serving as the head and advisor scientist G in the Department of Science and Technology, and he is heading many departments over there like SEED, SSS, TB, National Geospatial Program, etc. So he is a very renowned person, and we interact with, I mean, so being from DST, we have opportunity to interact with him directly or indirectly in many terms. Dr. Datta has completed his PhD from Indian Agricultural Research Institute, New Delhi. He joined agricultural research as an agricultural research scientist in Indian Council of Agricultural Research. He was awarded the Senior Professional Research Fellowship on Groundwater Governance. So in continuation with Professor Kaza, he is also a groundwater expert or person who can give more light on groundwater related issues. His area of expertise is, of course, geoinformatics and natural resource management. He's also expert in watershed management technologies and capacity building for local level planning, international and science, cooperation, etc. He has a number of publications in national and international journals and books. Today, Professor Datta will present about, will talk about sustainable water management using geospatial technology. A warm welcome to you, Professor Datta.
Thank you, Dr. Singh. I'm not renowned. First of all, I'm not renowned.
Oh, no, you are.
I'm a government officials in the Ministry of Science and Technology, managing the program, and in that context, like whatever the little experience I have. But today I'm not going to discuss about the the groundwater, but mostly about the application of the geospatial information, which is geospatial technology for the sustainable water management. Because as the focus here in these 3 days are the sustainable development goal and the technology usage. So in this context, I would like to share the presentation here. Just a minute. Just a minute. I think this is better to share from here. Is it visible, Dr. Singh?
Yes, Dr. Datta.
Okay. So what we are going to discuss today about that the applications of the geospatial technology and sustainable water management. Since like many of you may not be the you're exposed to these geospatial technology. So when we're saying the spatial and the spatial data means which gives a location, that the X and Y, like of a space of a place. So we call it geospatial data information, like the information from the data or geodata insights. So you get it in different forms like maps, satellite images, aerial photographs. Now also, you get that the UAV and the drone, the images. So as a textual and the statistical data. In India, the spatial data is basically the framework what we maintain is the Survey of India is the apex body. So it the basic the geospatial data. So there are many technologies in the geoinformatics. I'm not going into the details of the technology because my objective is in the context of a sustainable water, the management, how these technologies are being used. The basics of the geoinformatics technology are the database technology, remote sensing, which basically collects the data, the images, like it can be satellite based or in the other sources, like as you get now the UAV or the drone, the geographical information system, like which generate informations from the data and manages it to generate a new information, global positioning system, which gives you the location, decision support system, and the spatial data infrastructure. I will discuss more about the last two aspects because in the context of the sustainable water management, these are the two things like which are more important. So as from the water perspective, as you know that there are hydrological units, it can be divided into the regions, basins, sub-basins, and the watersheds. And if you look into the decision support system, a decision support system can be any computer systems, which be hardware and software, which is designed to support decision makers interactively in thinking about and making decisions. That means to generate different scenarios by linking the spatial and the non-spatial data. That means whenever there is a decision support system has three components of a database, a model, and the user interface. Whenever you add a GIS, it becomes the spatial decision support system. Actually, now in the context of the computer science, this is and now as in the intelligence system, sometime the artificial intelligence or the like as you see is the computer the models. So these are at the core of them. So in the context of how a decision support system is used for a sustainable water management, as you know, like any sustainable water management means that how judiciously you are using your the water, how much to withdraw, how much to to conserve, how much to use, and for that the core of it is the data. So the geospatial technology basically gives that the capability that how you can understand by changing the the different aspects of the soil water system and can understand that how the water there will be change in the water. Like this is at a basin scale. Suppose if you can change type of the land use, you can see that how the water yield due to change in the land use from a wetland to a forest will have an impact, which otherwise it's just very difficult, difficult to to understand and visualize. So this is the basically like the main advantage of the geospatial technology, where the the model and the data are linked in order to generate this scenario. Now, understanding the importance of an, like in the context of sustainable water management, which affects the human life and the livelihood. Like we developed a program called in the context of a small watershed. As you know, like in a small watersheds, there are watersheds, often very small size, where basically the upland, the water flow is more important than the the percolations. So the surface flow is more important than the what is going into the percolation. So it affects the the agroecological system. So understanding that we develop these programs in these 5 the locations of the country. where we took a set of the watersheds, which is a treated watershed and the untreated watershed, in order to understand that at a land use level, like the changing of them in different agroecological regions, how it is affecting the total the water balance. So as a result of that, we developed a standardized methodology of an hydrologic monitoring of the small watersheds, the standardized database for the management of these small watersheds, because for a sustainable water management, you have to basically standardize that the minimum the data requirement at a hydrometeorological level, the precipitation variations, as you can see here, and at the process parameters like infiltration, crop water, evapotranspiration, the soil moisture, and these are the groundwater flow, and the physical parameters like land surface, geological type, soil type, land use. So, so this was standardized through that. And then a standardized methodology for the data analysis by using the geospatial and the GIS models. Like, the model, for example, USLE is in one of the models because we use different type of model according to the different agroecological regions. So there is a database which result and the thematic maps and the GIS software, it generated different soil and water conservation planning scenarios. Like this is an example in of the soil erosions and the like the resulting soil erosion scenario in this is Bayakara watershed in Kerala. So as a result of that, what we developed a sustainable land and water management plan at two different levels. Level one, where we provided very local specific solutions for the watershed, which is a water balance study at the tabular way, water requirement, like, because this is the water balance is ultimately the sustainable water uses at the core of that. Then we do the water requirement study through the PRA method. Then at a level two, from this local specific to the regional level, like the regionalizations of the result to the other watershed in the same agrological zones by developing the rainfall runoff relationship, unit hydrograph method, separations of the surface runoff and the base flow through the hydrographs, and a flow duration curve in the estimating the groundwater reserve. So this methodology was ultimately, like we did it in the other, the different places, like as you see here, the silt yield and the water yield and the runoff. These are, and then simulated and observed. Ultimately, this was transferred to a capacity building of the local non-governmental organizations who are involved into this sustainable water management. For that, you use again the advantage of the geospatial information or the GIS by overlaying the administrative boundary on the hydrological boundary, so that it shows that because the administrative actions at a watershed level takes place on an administrative unit base. So unless and until we can integrate the administrative unit and the hydrological unit, it's very difficult for unsustainable the water management. So, at the context of the system modeling, which is a practical for an like the practical sustainable water management, we need to have in physical process modeling as well as the organizational process modeling also, because that, so for that there is an interface with the social science, so that we generate the the contextual informations in the context for sustainable water management. For example, if it is in the context of a government department, there the requirement at the level of the information is different. For a non-governmental organizations, NGOs who are working with the community, it is different. If it comes to a community level, the water management organizations, then it is different. So this is the way, we have brought the advantage of the geospatial technology in that in the the sustainable water management at the ground level. Now, if we look into these, the other type of technology which is being used for especially the geospatial technology, there are many, the drone-based technology. There are many now. We have a number of the sensors, which continuously collect the data, starting from soil sensors and the water level sensors for the irrigations. This is an example, this is an experiment we did, where the real-time soil moisture bed sprinkler irrigation system was developed, like this was done in the Indian Council of Agricultural Research. So, like there was also at the, back in, there was a modeling exercise was done, like, whenever there is the threshold value of the irrigation there, like automatically it was, the irrigation process was started. So this is another example where the geospatial, the UAV, or unmanned aerial vehicle was used for, collecting the large scale data, and like the different type of the plantations, depending upon the soil water, the availability was suggested, and it was, the implemented with a network of the non-governmental organizations. This is another technology, the SAR technology, the synthetic aperture radar, that which gives an, even in a very cloudy situations, which is an important for many places like in Kerala, like, to get this type of data. Now, from going into the very, the small watershed or the sub-watershed level, if you look into the sustainable water, the management at a basin, at the regional scale level, there are the geospatial technologies which are available are they called the the GRESS satellites. There are many satellites. Actually, there are a set of 2 satellites which are called GRESS. Like this was being launched by NASA as well as the the German space organizations. Here, the India is a partner to utilize this the data. So based on that, we have a the program of the regional scale, the hydrological basins, while the water, the total water system assessment, the glacier hydrology measurement, because that's the source, and with the climate change, there is a lot of change in the the glacier hydrology, then the groundwater variation, the crustal deformations and the geodynamics, because this the basic of this the GRESS this satellite is the change in the gravity anomaly. Like it measures the gravity anomaly, and with these 2 satellites, it continuously measures that, and which can be converted into, like this type of an anomaly based different physical the parameters. So this is very useful for measuring that at the regional scale, at a basin scale, that the total water the water management.
Dr. Datta, you have 5 more minutes, please.
Okay, sure. So now coming to like these data collections, there is another the technology which is available is the, like once you get the data, like how you can make it available, like through a common print. That is a spatial data infrastructure. So the spatial data infrastructure has the aspects of technology standards. And in India, like there are many like in the context of the water, as like the ISRO has a Bhuban, and this Water Resource Information System of India. Like this is the the SDI, the water SDI, which is available. I'm going a little quickly. Like this is the example, like how it is, that type of an SDI has been used at a local level for the sustainable water management. I'm not like going into the details it shows. So ultimately, how this technologies can really be converted into the sustainable water management. As you know, that this out of this 17, like there is a UN group of geoinformation management who have developed a geospatial, the data management framework, and like, as you see here, like these are for the measurement of these global indicators. So they are basically helpful in measuring all the indicators related to these water, that is 6.1, 6.2. Then is the 6.3 and 6.4 and 6.5, like which is integrated water resource management. And we have a national indicator framework also out of it, which is our and out of this is an example where we have used these technologies and like geospatial technology at a field level to like this is in a state of the northern Bihar and UP, where there's a water logging is there, so that this created like sustainable not only the water management but also the development of the livelihood of the people. So in this way, like that the technology driven the like water resource management and its impact on the life and livelihood, this becomes at the center of the government of India's focus on the self-reliant or Atmanirbhar Bharat Abhiyan. So I think That's what I wanted to share with you within the time frame available. Thank you, Dr. Singh.
Thank you very much, Dr. Datta, for such a captivating presentation. It's definitely this geoinformatics tools and remote sensing, all these things are it's a state of the art, and it's the need. We all have to use them in one or the other way. And they are very promising tools coming up, like you talked about GRACE and other satellites. They have so much more potential to explore, and they have added on different dimension to the existing groundwater or actually hydrological cycle in general. So that's really something very interesting. As a scientist, we are seeing much progress in the last few decades. I was wondering, do we have such kind, in Europe or European countries, where they have kind of a group which collect data, and they have a international science soil moisture community, let's say. So they have where all data are collected in one platform, and if you need something from Germany, or you want anything from Netherlands, you go to that data set and you have everything. For India, do we have such kind of platform, or are we planning to make such kind of platform? Because soil moisture data is very essential for many validation and analysis, but it's hard to get at a higher resolution. Unlike we get it from remote sensing.
Actually, the concept of the data infrastructure is the scale independent. You can get a data of the different scale, and exactly as you were saying, the hydrological data at a central place. There is the Central Water Commission has initiatives of keeping the hydrological data, and the soil moisture data and the soil moisture related data. Indian Council of the Agricultural Research (ICAR) has a central this type of data infrastructure from the National Bureau of Soil Survey and Land Use Planning, which at a national level, we have the National Spatial Data Infrastructure, as I was sharing with you. So the National Spatial Data, through National Spatial Data Infrastructure, all this data gets standardized and make it accessible and available to the users. So the answer to your questions are that yes, there are national level initiatives are there, which needs to be strengthened by many more partners to join there as a contributor as well as a user. Unless there is a using the pull factor in terms of using, and also continuous contributions in terms of upskilling, it cannot be a vibrant system, as you have already mentioned. You see in the geo in European Union or in US, as you see.
Yes, sir. So, also, I saw in US, they have very wide outreach program, especially for soil moisture collection. They go to schools and they demonstrate kind of small tools. How can you use it? So, for high school students, it's really interesting experiment. They can just have a small place. It's a very cheap equipment, so to say, and. I think we can also have this, or I don't know if we already have such kind of outreach.
Already we have there, at a school level, this type of programs are already there. This is from our ministries. They are also from the Ministry of Environment. It is there, and also from the Ministry of Water Resources, because as you know, that now there is a huge, the focus of the government on the water resource, the management, and also the ICR systems. They have developed this type of the cost-effective equipment which are being used, and at a school level also this type of an awareness creation. There are programs available.
So I was impressed by the way there was a program in NASA. So they had kind of a small certificate kind of a thing that students will get a certificate that they participated in NASA or something. I was thinking if we have similar structure, something similar we launch, like where students in high school get some certificate from ISRO, for example, then it is something they can sell better, like they can show that they participated in such program, and we can get data from different location.
Actually, for the school students with the ISROs, and also in some of the states, like where these activities are from, like I will be truthful that it is not equally active in all the states, but there are certain states like in Gujarat or in like near Hyderabad or in Karnataka. These are very the active, where like these are at a school level. There are a lot of programs which ISRO provides this type of certificates to the people. Like other than the ISRO, also there are many other Department of Science and Technology related programs are there, where students get this type of an exposure and get this type of certificates for their motivation.
Okay, where do we reach out for this? Let's say for DST. If we want
from the DST, there is a program called the NCSTC, National Council of Science and Technology Communications. You can reach out to them, and in the context of this program itself, you can reach out to us, the National Geospatial Program, where we do this type of a program also with the students for their capacity.
Okay. Okay, there are many important resources we can get from you. So this is such an like opportunity to talk to you about all this, and I mean about the availability of different data, like groundwater data. We have just the central groundwater board, and that too, I think, I mean, we have limited data available from there. Is it that the collection of data is limited, or is it that for public there are limited data available?
I think like as a government servant, I have to be very the balance. It's basically but as a citizen, I can say it's more the accessibility and availability of the data is the challenge, and that's what now government is working on, so that that the availability and accessibility can be made more available. Collection of data is not a problem because there is a regular system of the collections of the data, but its availability and accessibility.
Okay, I hope this works out soon so that we can do good research.
Yeah, but the country is large, and our diversity is large. Also, challenges are large also in terms of the data availability, especially in the current the cyber physical conditions across the country. So so in that context, we have to think it also. So these are the challenges, but government is doing not to bring it, like therefore I shared with you the data infrastructure, the concept where we are trying to make this data standardized and make it available to a single.
Yeah. Thank you very much, Dr. Datta. It's wonderful talking. Thank you so much.
Yeah, welcome. Okay, bye.
Bye-bye.
Thank you for the opportunity. Bye-bye.
So now we have next presentation, Professor Tammy Ronan Rosebaum. Professor Rosebaum is head of Renata Adler Memorial Research Center from the University of Tel Aviv. She's working on child welfare and protection department, and she has received many international recognition, which has published many papers and articles, books on children therapy, with cognitive therapy with children and adolescents. Her recently published book on cognitive behavior therapy in clinical social work practice is highly acclaimed and is well read. Her focused research area is positive psychology, subject of well-being, happiness among children and adolescents, aggression, cause and explanation, aggression, cause and explanation, self-control skills among children, which is such an important need, especially in this age of COVID, where all these things are getting even more complicated with their limited exposure to real life. Um, uh, Professor Rosbaum is going to talk today about helping people to help themselves, that is, educating the community around water sustainability. A very warm welcome to Professor Rosbaum. We are excited to hear from you.
Thank you very, very much for the nice introduction. I'm very happy to be with you. I'm sorry I haven't seen India for the last 2 years, and I do hope to come very quickly. I would like to thank everyone for arranging this week and for asking me to join you. And I think it's very, very important that in spite of everything, you keep working and doing the great work you're doing. Can you see my screen?
Yes, we can see you.
Okay, so for the next few minutes, I would like to talk about the way we can work with the community, because working on water and sustainable development in general and water in particular is of very great importance. However, the question I would like to ask today is how can we achieve these goals of helping people, families, society change? And can human actually change? Can human help other humans change? Are there some form of change which are better than others? And what is the social responsibility that may help this process? Because if we want everyone to have an access to good, pure, clean water, we need to make a major change. And change are things that are not easy to apply. And therefore, we need to understand some of the most important role of change. So let's take a few minutes to talk about what is change. First of all, the important issue that people can always be changed. If they weren't able to be changed, we wouldn't be able to work with them. But we know that as old, as sick, as problems they have, they can still change. And this is very basic knowledge for our work. We have to know that change is a process, and successful change necessitates goals, motivation, clear process, because from some studies, review, evaluation, bringing new technology to people and tell them just use it will not help. We need to know how to do it. So we need to integrate.
Sorry to interrupt you, Professor. Can you put the presentation mode, slides in presentation mode?
Let's see. Can you see it? Can you see the slide?
Yes, I can see it now. Thank you very much.
Okay, sorry. So we say that just telling people what change need to be done is not good enough, because we need to educate them, and education means that we need knowledge is not enough. We need knowledge, training, and application. You can tell me as much as you want how to work my computer, until I try it and I experience, it will not work, because I learn from trying and exploring things. So clear reasoning, why change is needed, what will be better, how will it be better, is also very important, because if people don't understand why they need it, what will be better, what can be improved, if they don't have a dream, the dream will never become true. So some of the facts regarding change and change theory in general is that crucial concepts are motivation, self-efficacy belief, goal setting. We all understand the issue of motivation. If we're not motivated, we will not do anything. but it's not enough to be motivated. We need to believe in ourselves. If I don't believe that my change, my work, my new application will help and make some change, I will never do it. So we need to set on the self-efficacy belief, and only then we can put on some practical goals for working. And as I mentioned, we were not interested in just make a change, and as we leave, the change disappear. We're interested in the long-lasting change that will be sustainable, and therefore the way to apply it is very important. I think that another important fact is that no one can change others. I can be as good, as expert, as wonderful as possible. No one will change because I tell them to change. The only change people can really achieve is the change that they create for themselves. Therefore, our goals is to educate and help people believe and understand, but the only real good change is the change that people apply for themselves. So, as I mentioned, our responsibilities will therefore be to educate, explain, and clarify, to increase motivation. And a very crucial issue is to apply skills. Sometimes we take things for granted, and we think that if we explain, that's enough, which is not. Therefore, we have to work with people and empower them with the needed skills to apply change. And another issue is the ability to integrate, generalize, and generate the sustainable change, because we don't want to work on each separate little issue. We want to be able to generalize it for a broader range of change. Gordon Paul, many years ago, talked about the major variables and domains involved in change process, and to show where errors have occurred in past investigation, and to serve as a basis for determining the degree of control necessary to answer the varied question. So if we look at Gordon Paul question, and he investigated it a lot, now everyone uses it, but the W question he was talking about, and we will look at it soon, the origin of it go back to Hermagoras of Temenos and Aristotle, that developed into the originator of the elements of circumstances. An ancient Chinese classic, I Ching, that developed into the how of change. And the how of change that Paul Gordon talked about are the W question: who, what, when, where, why. And I think we need to add the how, because we want to think who can really make the change, what kind of change is needed, when is the best time to apply change, where is the best place to apply change, why change is needed, only for making change, or do we have other reason? But the question of how is very important. Often we come and apply project because we can, because we feel like, but we don't really investigate the preliminary issues that based on this question. So we need the knowledge of what and who question, and we need the process of how. How can we do it? How do we select the problem for change? How can we increase motivation for change? How do we work with the people? How can we use their strengths and virtues? And everyone has strengths and virtues and resources that if we are smart enough to use it, we can increase change process. So While talking about change, we actually collaborate three different kind of theories that are very important for this area. One is the system theory that talks about the system, what is a system, how we save the system. So we can look at a village, for example, as a system, because when we want to come and apply change, we want to save and leave the original system of the village. We don't want to break it. We don't want to change it. We want to reserve the building of the community, but to let it be more flexible. We have to base on learning theories, cognitive behavior theories, social theories that relate to issues such as how to reinforce, how to greet people, how to use operant conditioning or other kind of learning method to increase change. And an important issue is relating to the basic belief system, because if I use to irrigate the land in a special way, and my father and great grandfather and great grandfather did the same, why should I change? If I don't understand the logic of changing it, if I don't understand that by changing it, I don't go against my family tradition. I just progress to new knowledge, technology, and idea that can take what they innovated in their time, but bring it to my time. I won't be able to make change because my basic belief system is very crucial to begin change. And positive psychology is also important because we all want to be happy, to be satisfied, to flourish, and we need to understand that the role of change, the kind of change we're talking about, is to increase hope, optimism, meaning, support. And one of the main issue of positive psychology is support, family, social, community support, which should be very important component of change, as well as meaning. Change has to mean a lot for me. If I have no meaningful in that, I will never do it. I'd like to mention another fact is the Jay Haley that came from family therapy, talk about first and second order change. First order change means to do again and again the same thing. So if I try to apply some change and it was not working, I will do more and more and more of the same. But if it didn't work to begin with, why should I bother continue doing it? Second order change means that if I tried some change and it was not working, maybe I should be more flexible. Maybe I should think differently. Maybe I should go to another way, another link, another trial to apply some different way of making change. And maybe this time it will be of more help. So I'd like to show you before I end a model that I've been studied a lot in different projects and found it as valid and reliable for making change sustainable. And I've done it with people, human, families, community, and national project. And not only that I can talk now about what are the components that help us achieve change, but I can also talk about the order, what leads to what. So if we look at this, supposed to be circle, but it was easier to draw it this way, circle of change because it never ends, we are talking about mainly two paths, individual path and community path. And the first part will be to make decision about areas need to be changed. When we want to start talking about applying new idea, new technology, change issue, we need to ask what are the causes, what are the wishful outcomes we want to achieve, what are the risks, setback, and challenges. And this should be the preliminary change for starting to work and understand what we're talking about. Once we're clear about that, the second issue will be, can you see some way?
Yes, we can see the slides. So right now you are showing the slide on models for helping people change.
Do you see the model?
Yes, we can see that.
It disappeared from my screen. So this leads to the first individual path, which will collaborate cognitive, emotional, and behavioral component. The cognitive part will be reconstruction or redefinition of the needed change. Try to work on my basic idea. Why do I believe change is necessary? What is important in change? What is my automatic thoughts regarding change? How do I look at it? And sometimes we need to put lots of effort in trying to talk with people about it. That leads to attentional focus, which is more our sensation and emotion regarding change. Because if I'm very stressed and anxious and fear about change, then maybe I will not allow it to be happen. So increasing awareness to my response, trying to feel more relaxed and certain about the change is very crucial. Then we need to look at the behavior, because the behavior is an outcome of the way I think and the way I feel. So if I change my way of thinking, I will also change the way I feel and the way I behave. So we need to understand that in order to make change, we all want to achieve big, crucial, important change, but we can never achieve the big change. We can achieve very small steps, very small changes. And once we collaborate another small and another small and another small steps, we can achieve the big change. In order of actually doing it, we need to identify our strengths. Each of us have strengths. And if we understand our strengths and our skills, we can use it to help ourselves experience change. But we're not alone. We're only part of the community and the environment. So if we look at the environmental path, there is the motivation of the community, the village, the family, and we need to, and therefore, if we identify the early adopters and understand who they are and take them with us, they will be our ambassadors for applying change.
Professor Rosenbaum, you have 2 more minutes, 3 more minutes.
Okay.
Yeah.
That's okay.
Thank you.
So I was talking about the personal strengths, but there is the community strengths, because each community, each family, each village characterized by some special strengths and virtues. And if we understand the DNA of the place we're going to work with, we can mobilize it and take it with us to apply change. We also have to understand the resources and support in the environment, and sometimes we ignore it, but people are smart People live there, people know better than we do what can help, and we can use this. And then we can work on generalization and integration and work with the policy makers and the public and the governors. But the last one I'd like to mention now is the importance of assessment. Because if we want things to sustain, we need to assess and understand what have we done right, what have we done wrong, what we can improve for next time, what should be better goals and function to apply change. And then we can continue for another area of change. So just to sum up, I think that whatever I heard before and read and know of many of your work, everyone is doing great work, which is very important. I think what we need is to collaborate all our efforts, technology, culture, human change process, to work together on all elements, and then we can make sure that good change will happen and we will have a better future. Thank you very much for listening.
Thank you very much, Professor. It's such an interesting talk about how do we motivate people and how we can initiate change and make step-by-step process. I mean, also when we go to field, we can see that, like you said, it's why one generation would agree with something which they were practicing from generations. Why all of a sudden somebody will agree to change if we say, no, you shouldn't do, for example, if we talk about water, you shouldn't do the kind of irrigation practice you were doing. Instead, use drip irrigation or some precision irrigation. Expensive for them. Maybe government can pitch in and support in the sense they can financially support the farmer, but still mentally it's hard for them to accept that no, this is not the best way to irrigate. So this change. To make this their mindset ready for this is a challenging task. And what would be your, in that sense, in that context, what would be your advice for even for the researchers like us who go to field and talk to people? How do we convince them that it's their, I mean, other than talking about the benefit of technology, is there some subtle method which you may advise us to keep in mind when we want to talk about changing their way of life or their approach of doing things in whatever context we want?
Well, I think you raised some very important issue. I believe that everyone is motivated. No one is against, but if people are not motivated, it's because they're afraid of something or they don't know. So I believe that a good starting point is to talk with the people and ask, what is your dream? What do you think will improve your life? What would you like to have better? And then lead them to say that good water, different way of using water is very important for them. Because when we come and say it's not good enough, the fact that they read numbers and studies and things, that's not working. We have to come sometimes to do experiment and to show them, sometimes to talk about health and education and easier life and convince that it is important. If people understand that this is important, not because I want to do it. I'm not a seller. I don't want to sell you something. It's not for me. It's for your best benefit. Then it will be easier. So we need to find what is difficult for people, what hurts them, what can improve their life, and try to convince that this is the way to improve their life. Actually, I am now the head of the program of sustainable development, international program in Tel Aviv University. And the reason I started this program is because I decided that we need to do something multidisciplinary, that engineers and economists and people who work with culture and psychology and policy will work together, teach together, and design a modular program for change that everyone will put this element. I believe that together we can do it. I think that modeling is very important, not only to talk about change, but to show how we do it, to model the way we work on it. But this is a process. Yeah.
That's very, very nicely you put it. And yeah, in continuation with that, we have also another question from Dr. Sudha. So she is asking if there is a huge movement, like you were saying that it is a process, and she's asking about it. So is there a huge movement in your country or in your project groups to integrate the local and traditional knowledge into understanding and motivating your population to be pro-sustainable?
I don't know if I can talk about a huge movement, but I can talk about the fact that more and more we understand that it's not only the technology and it's not only the economy, but there are more processes. One of the things I'm working about now is the difference between satisfaction with life and happiness. You read lots of information about happy countries, and actually they don't talk about happiness. They talk about satisfaction with life, because if I earn more money, I'm more satisfied. But I will not be happy unless there are some meaning to my life. I think that if we collaborate with people regarding meaning of their life, relationships, support, if we work with a community, it will be easier because I will not go against my family. So I think there are some places that understand it more and more in Israel, but we also are in the beginning because everyone did their own work and wonderful things have been done, but we're not good enough in tying all the links together. And I think that once we're able to do it, we will do lots of work. We could see at the corona here in Israel, when they talk about medical condition and fear and strength, people did not comply. We had a group that consulted the country how to convey information and to let them understand that fear is not helping. You have to give people the power and to tell them you're responsible for it. You can make a better change. You can make us be healthier, and then people comply. So all tides are need to be together.
Yeah, I think this is like you very nicely said, and that's really something intriguing. That it's not always money or technology. There is some subtle part of it which we often miss. That we are human and we have some psychological part of handling things. So other than economic and direct gain. So that has to be understood properly and taken care whenever we try to initiate any change for that.
That's true. I agree. I can do nothing without the technology, but the technology cannot do anything without technology. So we need to work together, and we know that together we're better. So
certainly. Thank you very much, Professor, for the interesting talk. Thank you so much.
Thank you. Thank you very much.
Now we have Professor Jaspa, Tarun Kumar, sorry. Mr. Kumar is a founder and CEO of EcoStep Technology Private Limited, Bangalore. He has expertise in sustainable solution in sewage treatment and toilet to tap. So their mission is to reclaim every drop of water, wastewater, naturally. The team has created a unique zero power, zero operator IoT sensor, which enables sewage treatment product to disrupt the current model of using power hogging motors to treat the sewage. The product is a replica of cow's stomach, actually, based on biomimicry concept. So Mr. Kumar will talk about this biomimicry and learning from nature in today's talk. Thank you very much, Professor Dr. Kumar, for joining us. The floor is over to you.
Thank you, Dr. Alka. Let me screen share. Visible?
Yes.
Yeah. Good evening again. Good morning, good evening, whichever country you're calling from. So this is about learning from nature, biomimicry. My name is Tarun Kumar. I'm the founder and CEO of Technologies. We have a sewage treatment product which is based on a custom, which I'll explain in a minute. Define the definition. It's a practice that learns and mimics the strategies found in nature and to solve the problems. And of course, find hope. That's a key thing. It's about copying nature. And a great quote is from Janine. Janine is my kind of guru. She runs the Biomimicry Institute based out of US, Montana, who's our technical mentors. We've been mentored by them. So what she says is there are 3.8 billion years of learning in nature. 3.8 billion years of learning, imagine. Right? So birds started 4.5 billion years ago, the Earth. And 3.8 billion years is where the life formed. And last 200,000 years where humans came. And that's why we messed it up. But we learned a lot in the process. And how do we learn that and to really put practice? So a few examples quickly. The kingfisher is a great example. Kingfisher and the bullet train. The Japanese bullet train, the Shinkansen bullet train, was originally with a flat surface, which used to create a tunnel boom. So when you go to the tunnel and exit, there's a huge booming sound because of this. So which has been, the scientists came out with they just copied the simple solution. So copied the beak and made it longer, and the sound went off, and also became 10% faster. So it's often quoted the example of biomimicry. Other than this is the Velcro, the famous Velcro. This is a Dr. George Mister in 1941 was taken out for a dog for a walk, and after the walk he found a lot of burrs on the dog. And when he removed the burr, he found it's all small miniature tentacles, and he formed a company called Velcro, and that's it. And when Velcro is a great example of learning from nature. So there is tons of examples. Some are simple copy, some are detailed copy. We'll get into it. But the Steve Jobs quote is very, very pertinent. The biggest innovation of this century is the intersection of biology and technology. And innovation always comes from the intersection. Shark skin is a great example. I mean, I don't know, we would have read about this. If you look at a shark skin, the shark glides to water. The glide is a key word. It glides to water so fast because the skin is it's got a lot of denticles or little teeth, it's called. So small grooves. That's how it goes so fast, right? So it's nature, again, they've survived for a long time, so evolved over a period of time. So this company, Speedo just copied this. Speedo is world leader in swimwear. They just copied this. They put the Speedo's, the famous model was a laser. You wear the swimwear with the grooves in it, and you get a 15% gain in drag. And imagine when you run in Olympics and all, 15% gain in drag is huge. It's huge. And many people, most Americans use this thing, and it's a very unfair advantage. That's why it got banned. And guess what? Who did the great thing? Michael Shepps He was wearing this during this Olympics. And last, you all know, Beijing Olympics, he won 8 gold medals. Imagine someone in Olympics winning 8 gold medals. And he's winning. It's not to say that just because wearing the dress, he got the gold medal. No, it's not a hard work. He's a god. But he normally wins 5 gold medals or 4 gold medals. But Beijing, he won 8. Perhaps the extra few golds would have been come from this shark skin wear. So that's why it got banned. But imagine the possibility, right? So another example is the bats. Now, bats, the good old bats, though many people don't like them now because of COVID and all, but it's amazing to learn how they work. So today's avionics, the radar, all came from the bats. So if you look a little deeper, especially I'm quoting from the book, the sound is generated by 3 things, by the larynx, the tongue, or the nostrils. So different bat, different types. It's not even a standard. So that's a beauty. And I'll explain in the biochemistry session wherein how the function and the shape works. So if it's a nostril, means the nostril is designed to be like a megaphone. So it's been designed like this. And then comes the pitch. It does ultrasonic, 20 to 200 kilohertz ultrasonic pitch. The decibel, the sound also goes up and down, and the duration in milliseconds. So it's a combo of 3 things together. And to add more to the complexity, more layers, it does constant frequency and frequency modulation both together. And it can go as long as 50 dB and as high as 120 dB. It just goes up and down. And this is how they communicate. Just imagine, you close your eyes, you're in a dark room, and you want to get way out. You can always find a way out. But how do you find food? Where is my pizza, right? That you need some additional skills. And that's where the bats can come in. They can find a way out. They can also catch a prey because of this advanced technique. And go more deeper. Suppose I do it 120 dB. I'll become deaf. It's so loud. Though we can't hear it because ultrasonic. So that's a technique for it. The middle ear muscle, it just contracts, and 3 bones close in. Got the malleus, incus, and stapes. They just close it, and you don't hear the sound. And then it again relaxes and comes out. And it all happens in milliseconds. It's amazing. And the last point is about the structure of the ears. I mentioned about the structure of the ears. Shape is a huge thing in nature. So the wrinkle, the shapes, and that's how they catch the sound, and that's how they learn and go with that kind of precision. So amazing example of the bat. So this is about you should watch this. The BBC, the link is down. The BBC program called 30 Animals, where we really gained. 30 Animals is they took a 25-minute sections on amazing animation and explained how it works. In fact, one of them is ecostropy, but this one I love. This is about a wasp putting an egg on an animal. So the wily guy, just go in, makes a small prick, and then 2 more slides comes in a horizontal manner. The animal doesn't even know. It's slowly, and the egg is put and comes out beautifully, no pain, nothing. And now the new surgical tool has been coming out, and it's not easy. You have to have the first prick, and the second one, third one should glide in through. But technically possible. There's a way. This is how the animals have been doing, and this has been learned over millions of years. Cows, and the example I mentioned is one of the things featured in cow. Where is cow and where is sewage treatment? Totally different issues, right? I have a big problem, and we get inspiration from the cow. Because if you look at sewage today is based on how do you blow air. In the last 30, 40 years, you have seen sewage treatment systems always blow air. You blow air through fecal matter, and that's the whole area smells. And you blow air, and that's aerobic bacteria that works, and that's how the bad water becomes good water, which works, which needs power, chemicals, operators, etc. But how does nature treat it all these years? All the 3.8 billions of years, we never had this blowing air business, right? So it's because of anaerobic digestion. Anaerobic digestion is what works. And who does anaerobic digestion the best? Cows. A cow's stomach does amazing anaerobic digestion. This is how it looks like. So the 3-4 stages of cow stomach called rumen, reticulum, ovomasum are copied in a stage 1, stage 2, stage 3 civil structures wherein the water goes from one tank to another one by gravity up and down like in a river motion, and you have clear water out. We just copy the whole thing. There's a lot of intricate mechanisms. It's a lot of clever engineering, but fundamentally a 12-stage anaerobic digestion system mimicking the cow stomach. We even mimic the cow's walls. Cow's walls are roughness. If you look at, there's a lot of fillets and the bacteria around it. So how do you mimic the roughness of a cow stomach, which is so important? So we use something called stucco plastering, where the walls are all rough, not smooth. That's how we do the mimicking. So small details. That's how we done it. And this is how we look like. The whole thing is we call what we call the guts of a sewage treatment system. It's complete civil structures, lot of multiple pipes, channels. But once it's done, it goes underground. You don't even see it. And this is how it look like once it's all done. Right? It's all beautifully done. No noise, nothing. It's an apartment in Bangalore. Below the children's playground is the STP, sewage treatment plant. You only know it is there. These kids are playing, and this is how nature intended. We never wanted this noise, etc., etc. And coming back to how sustainable it is, right? That's always a question of how sustainable it is. So we conform to 6 SDGs. We conform to number 3, good health. Number 6, clean water. 8, decent work. Number 9, industry. Number 11, sustainable cities. And number 12, responsible consumption. Right? And this is not what I'm saying, is because why I'm saying this is everyone says everybody is SDG. Everybody says SDGs. But how do you know how many are really SDGs or not? So we got 180-degree consulting from IIT Madras to do a study and tell us how much exactly you comply. And they said 6. Well enough, 6 enough. Right? So that's how. So this is how, when you do sewage treatment, it should be sustainable, right? And on the left is a nice example which you're doing now. Right now, this is for a 200 KLD STP we're doing for Chinmaya mission in Kochi. So Chinmaya mission is starting a new education institute in Kochi, and they want to put in STP. They had to put STP as the law. So they compared and chose us. The few things which we gain by putting our STP is they save 131 megawatts power every year. They say, because if you don't put our STP, you have to put a normal power-based STP. They save 105 tons coal every year. They save 60 million liters of water, good water. And lastly, it's nice to talk about sustainability, but if you don't make money, it's not sustainable. So they save 12 lakh rupees a year by using EcoStream, right? So that's how. So it's not about treating bad water to good water. Can you make it sustainable? Can you leave it long? Can you leave it last long? And that's a key message. Now let me slowly switch gear. Let me go a little deeper to biomimicry, right? Now, what is biomimicry all about? How do you ensure one is biomimicry and another is not biomimicry? How do you raise your growth to deeper levels of biomimicry? And there's a biomimicry toolbox. The link is down where you can learn. There are 10 key principles or life principles. How do you define biomimicry? It's a framework. And I'll just quickly go through each of them, not in detail, but I'll go through each of them. Number 1 is nature uses only energy it needs and relies what is free. Last, the 4th, decomposing organic material, nutrients from animals and plants. All of them is available. You have to look through it. You don't need to switch on your light. There are so many other ways to. It's not only sunlight. There are so many other ways to you can get the link. Second is nature recycles all materials. Every material is recycled. Is always nature does everything recycles. It breaks down. For example, any bigger components broken down small one. You have a centipede and a millipede. They break it down. Then you go to the bacteria and algae and fungi. Everything gets broken down to the smallest bit, right? In our case, when we compare EcoSTP with the unifying pattern number 2, which will explain later in our framework document. So even the waste, even the sludge is decomposed to digestate. So the bacteria breaks down everything to the smallest component to digestate. So whatever, that's how the nature works. Nature resilient to disturbance, obviously. Nature is designed for resilience management. So key 4 principles: diversity, the 3rd line, diversity, nature's by design diverse. Redundancy, there's always a backup for another one. Decentralization, nature never has a centralized thing, it's always decentralized. So one goes, another one is there. And lastly, the self-renewal and self-repair, amazing principles which nature. So this is only a pitch. The link, you can send me more details. You can have more details, information on this. Number 4, nature optimizes than maximizes. This is very good for human beings. We always want to maximize, right? So look at the last line. Growth for growth's sake will result in harmful side effects. We all want to grow, but do you really need to grow? When use only what you need. Nature doesn't do that. Nature does only what's required. You just don't grow super fast. Number 5, nature provides mutual benefit. It's always a symbiotic relationship. It's always both sides win. It's not only one person wins, right? So rule number 5, unifying pattern number 5. So each of them helps each other. And in our ecosystem also, we have the same thing. We have evidence of how does these two work together. Important, nature runs on information. My God, the way it runs information is amazing. If you read the line number 3, the system of send, receive, and respond has been fine-tuned over millions of years of evolution, right? It's not today, yesterday. That's how the information system works. Both negative feedback and positive feedback. Negative feedback means slow down a process. There's too much negative thing to slow down. Or positive feedback means speed up a process. So in our STP, there's too much food coming in, too much waste coming in. So bacteria multiplies. How does the bacteria know that more food is coming? That's how the positive feedback, okay, more food is coming, lot of people are flushing, let me multiply. So it's all designed. That's how nature designed. Which normal STP, it doesn't do it. The normal STP is like, I'm stuck, I'm designed for X, and that's it, I respond. So nature, when you mimic ways from nature, these are the 2 things which you get. Number 7, chemistry. Chemistry, you all talk about green chemistry, but it's amazing how nature intended. Nature takes only 11 of the, you all know, the periodic table is around 118 elements we have. We human beings, we use all or most of them, right? Nature takes only 11 and only 4, in fact. Just carbon, hydrogen, nitrogen, oxygen. That's all you need for most of the, that's all I need. Minimalism, right? I don't need to, I need more. And if I need more, I use it if it's locally available. Otherwise, I don't even touch at all. That's how the nature intended, which is a great lesson for us. Again, if you're a biomimicry company, how do you map with this? How do you compare with this pattern? Number 7 is important. Number 8.
Mr. Kumar, sorry to interrupt. You have 5 more minutes, please.
Great. That's all I need.
Thank you.
Number 8, we have number 8 is nature builds on abundant resources, right? And use only what is required, right? If you look at rare resources, we'll rarely use it, right? So if you look at last line, rare materials that is locally available and readily available, not mined, processed, or shipped from thousands of miles away. Is all. So that's how nature designed. So why do you want to use the whole thing? Just because available, don't do it. Use only what's required. Number 9, nature is locally attuned and responsive. Right? Locally attuned and responsive. That means you use local resources as much as possible. Now I'll just take a minute on this, right, to compare with the how EcoSTP maps with this. Right now, I have a client in, we just won a deal in Coimbatore, where Amrita is based, for a tri-square villas. So for a Coimbatore STP, I can make one STP from Bangalore and send it out, but it's expensive. I have to make from here, make it, ship it, transportation, diesel, etc. Instead of that, I can do it locally. So I don't sell the STP, I only sell the license, I only sell the kit, how to do it. And it's locally made, using locally available materials. For example, recently we done for in Chikmagalur, an STP made of mud bricks. So STP is made of mud bricks using local materials, not centrally shipped from, not a RCC concrete ones done from remotes. So again, mapping with the unifying pattern number 9. And last number 10 is the how do you shape to determine functionality. Shape is huge in nature. Nature, as the first line says, uses shape or form rather than materials or energy. Materials and energy all come secondary. First is shape. I make the shape first. And then only I use materials and energy as required. But fundamental is shape, right? And then we've seen the example of the bat, how the bats, their shapes happen. We've seen how the shark skin, the form of the thing. So shape and form, and these are it's a pure science. Like the beetle's back, you can take a beetle back. A beetle back collects the water. And in a desert beetle, where is the water in the desert? But the beetle collects water in a desert through the grooves on the back, purely form. Purely form, it collects, makes the grooves, the water condenses, straight goes to the mouth of the beetle. This is my links, multiple links are there. I'll start from the bottom one. The ecosystem.com resources that's a sustainability frameworks white paper, which explains this 10 principles in biomimicry. How does ecosystem map? So you can use as a nice model. Whatever you do in biomimicry, you can map it to it. Okay, am I doing 10, or am I doing only 8, or am I doing only 6, or how deep you're doing? The second is the 30 animals that made us smarter. This is another great one. There are amazing animals. Animation, you should see this. Cow is mentioned in one of them. And the top one, okay, now we learned how to do this. I want to do this biomimicry. Where do you learn? This is the way to go. Ask nature.org. It's a free site. Ask ask nature.org. It's a lot of ideas, a lot of data on how to do this. One of the things you should not miss is the one I think I put about the Fibonacci sequence of the sunflowers. How sunflowers, the way they plant, the 2, 4, and 6, how they in a spiral mode, how they work. It's amazing. You should watch it today, right? So this is all available in the and yeah, and this is my last slide. Hope I'm on time.
Yeah, such an interesting talk, Mr. Kumar. It's like we started from our gut brain and then expanded to entire nature. It's like, this is our saying in India, we have, there's the second brain in our stomach. So,
course,
yeah, and you have talked about how we can learn from nature in different aspects, and it's really so true that nature is the best guide, or we can learn so much from nature. I mean, all our evolution of our discoveries and technological invention in one or the other way is guided by nature. I was wondering this tool which you have. So it doesn't have any byproduct, or how does it handle the waste left after the processing?
Yeah, there are years. So we remove the sludge once, and that when is brown gold. So that's all. Water, not gas, but gas can be doing so completely based on nature. This is all nature. Only 100 installation, 20 days.
I don't know, maybe this internet was not very stable at my end, or I couldn't hear you properly, but maybe it's at my end only. Maybe I close my video, that will help.
Okay.
Yeah. So yeah, it is a super interesting talk. I mean, there is definitely so much to learn. Like it has, you said something about how you manage the flash or the remaining part of the processed water. I couldn't hear that.
Yeah, the water comes out. You use it for gardening usually, and we can also use it for flushing and car wash, and that's completely natural. Then you need additional filters which need power. Then you can use it for portable quality. For one client, we are giving drinking quality water from the sewage water, so that's doable. Yes.
Mm-hmm. So it's like we can use every drop of it in one or the other form.
Yes, every drop. Yeah.
That is super interesting, and super. I mean, it will be definitely. Can we expand it to a larger scale?
Of 1000 KLD. So it's something like 6,000 homes. That's max I can go. So this works on a decentralized concept. We don't believe in centralization. So we believe multiple STPs, eco-STPs can be placed to solve the problem than one large big one. Which large big one needs, a centralized one needs a lot of piping, digging the road, so that decentralize the whole thing and making small ones. So we come to that segment, decentralized systems.
We have some questions, Dr. Kumar. So there's from Dr. Sanjay Pal. He's asking if you can maybe throw more light about how you're connecting it with cow. because it's a little unclear that because cow gives cow dung, urine, methane, carbon dioxide, never pure water. So he was wondering that if anaerobic digester does not reduce um, the coliform count either. So how are we connecting it with cow?
Right. Yeah, a nice question. Let me explain both of them together. So a cow stomach is anaerobic digestion, and that is the world's best known aerobic digestion mission, so to speak. You can even digest cellulose. So that's why we copied that. And as a model, of course, I can't mimic 100%. So it's a 12-stage anaerobic digestion system in the real life, which of course gives methane gas, which I said we can recycle. And the whole tanks, when you put bad water in, it goes to multiple chambers. And we put a cow dung layer in the bottom, and the cow dung derived bacteria, which decomposes the waste. So all the waste that comes in, something like 300 to 400 BOD contaminant, breaks it down using anaerobic digestion, a 12-stage patented anaerobic digestion, and you have a clear water out. There's a 10 BOD output without using power of chemicals. And the anaerobic digestion, by design, that's what if you read up well, it actually reduces the coliform. It doesn't make you 100%, but it reduces by 4 log reduction. This is how natural systems are. Natural systems reduce the is all encompassing. You don't need a separate disinfectant. Of course, you need a disinfectant to make it 100% bacteria free, but lots of reduction which happen in anaerobic digestion if you design well. In fact, one of our companies called DRDO, they claim 99% pathogen free, right? So it's a 90%. So in STP, how can a sewage treatment reduce pathogen? It's possible because if you follow nature, it happens. When you do nature-based systems, it reduces the pathogens without using. In aerobic digestion, it doesn't reduce. You have to put chlorine and ozonation. Here also you have to do it. If you want to touch it, if you want to flush it, you have to use it. But normal purpose, you don't need it. And the HRT is 72 hours, hydraulic retention time. I can share more details for technical questions.
So what is HRT, Dr. Kumar?
72 hours, hydraulic retention time.
Hydro?
Retention time.
Oh, retention. Okay. So retention time, like how much it is, like?
72 hours. That is one place to another one takes 72 hours to come in. But that's more technical. Once the tanks are filled up, you put one bucket in, one bucket out. It's real time. But the entire process takes 72 hours.
Yeah, maybe Dr. Sanjay Pal can discuss with you in more detail because he seems having questions. And
Certainly.
It definitely is an interesting topic. So thank you very much, Mr. Kumar, for joining us and giving this interesting talk.
Thank you. Thanks a lot.
Thank you so much. Next in the line, we have Professor Jeff Pal. He is a professor in Durham University, UK. His research interest is in functional surfaces and surface science. He has completed his PhD in surface science from Cambridge University in 1988. He has multiple awards in his package. He is like he got King's College Fellowship and whatnot from 1988, and it was not that he just got awarded in the beginning of his career. He continued to get acclaimed with different awards. Even recently in 2018, he got Chemical Research Society of India Medal. In 1919, he has been elected as a foreign fellow of the National Academy of Science, India. Professor Pal is going to talk about nature-inspired surfaces for sustainable clean water. Warm welcome to Professor Pal. Floor is over to you.
Thank you very much. I'll just share my screen. Okay, good. Well, first of all, I would just like to thank the organizers of this symposium. It is a great honor to be invited to give a talk. So my talk is going to really follow on from the last talk, where we're going to talk about learning from nature to make sort of sustainable clean water processes. Okay, so the main area of our interest is generally to do with surfaces. And if you think about water, in particular, if you think about collecting water, or if you think about purifying water, the water has to come in contact with the surface. And so understanding what happens at these surfaces can help us to tackle some of these societal challenges. And as this slide shows, it requires a very sort of interdisciplinary, multidisciplinary approach to come up with technological solutions. And then obviously beyond that, as mentioned in the earlier talk, one has to work with society and implementation. So the overview of my talk is based around basically a little bit just telling you about how surfaces wet in the natural world. And then I'll tell you a little bit about, for example, how recently we've developed ways using natural processes to prevent the spread of coronavirus. And then we'll go on to talk about industrial and agricultural water pollutants, which is something which is important in India, I understand. And then I'll talk a little bit about oil water pollution, so especially oil spills. And finally, about how to collect water from the air where the groundwater is too contaminated. Okay, so just to very quickly start off, just in terms of how a droplet of water sits on a surface. So if we think about a droplet of water, it can either sit as a ball, and that's known as sort of a hydrophobic. So if you think about, for example, water droplets on the lotus leaf plant. Whereas if a surface makes a water droplet spread, so it completely wets the surface, that's known as hydrophilic. And then you have extremes of these. You can have super hydrophobic, as the little video on the right shows. That surface, the droplet will not actually sit on the surface at all. And you can also have super hydrophilic, which is number 4 at the bottom there, where the water just completely spreads. And so these are the concepts which have evolved in nature over hundreds of millions of years. And just to give you an example is that here we have a lotus leaf on the bottom left. And you can see the water droplets, they roll off, and that's basically to stop any bacteria sitting on the lotus leaf, which would then infect the lotus leaf plant, and it would deteriorate. But if you look at this sort of lotus leaf at different levels of magnification, as shown on the top 3 microscopy slides, you can see that nature has evolved in terms of coming up with the right chemistry, first of all. So these are basically plant waxes which form on the surface of the lotus leaf. And then also you can see the structure. There is a certain kind of roughness which traps air, and this stops the water droplet from coming into contact with the lotus leaf and therefore potentially infecting it if it has bacteria in it. So the way that we try to replicate these surfaces, we try to use a very eco-sustainable way. Basically, we use something called a plasma, which is basically the 4th state of matter. And most people come across this in everyday life in thunder and lightning. If you think about lightning bolts, that is basically a plasma. And this is to do with basically using renewable energy to basically activate chemicals without using any kind of solvents or waste materials. And if you do this, you can basically mimic the, first of all, the chemistry of plants in nature, and you can make very, very low surface energy, so very liquid repelling surfaces. So this is just like a smartphone which has been coated, for example. And because it stops all the water from getting inside the smartphone can keep operating. So this is an example of a nature-inspired technology which can be used for consumer products. And then these technologies have been scaled up through startup companies from our university, and these coatings are made all around the world. In fact, phones in India use these. And things like, over sort of 90% of the world's hearing aids now also have this technology, because hearing aids, again, especially in humid environments, you want to keep the moisture from getting inside the hearing aid. You can also sort of, again, learning from nature, there are plant surfaces which are very slippery, and they basically stop things from sitting on them. And this is actually a good way to sort of save cleaning water. So if you have surfaces which you don't have to rinse, then you can basically save cleaning water, and also you can improve food consumption, less food waste. So this is just a quick video showing sort of two vials, really. The one on they have tomato ketchup in. And you can see the one on the left, the tomato ketchup isn't coming out the vial because it doesn't have this slippery surface on it. Whereas the video on the right shows a vial with the slippery surface, and you can see all the food is dispensed. So there's no need to clean that, and that saves water. And again, it's to do with chemistry, so surface chemistry. And then just sort of moving on to sort of stopping waterborne transmission. So here, what we have done here is that we've basically looked again at natural products. So we've taken essential oil, for example, cinnamaldehyde from cinnamon sticks. We've taken tea, and we're very familiar on the bottom left here. We're familiar with the tea stain, which is obtained if you drink tea. And so we've used that to basically make coatings. Because the natural products like cinnamaldehyde from cinnamon oil is antibacterial, and there are other essential oils which are antiviral. So you can basically just brew some tea, some tea, and you can introduce some essential oil from a natural plant, and you can get antibacterial and antiviral properties. And again, you could apply this to a mask, or you could apply it to a filter for purifying water. And so it's quite a good sort of nature-inspired solution. Okay, so moving on to sort of industrial agricultural pollutants. So this actually affects everybody. It doesn't matter where you are in the world, because due to exposure to heavy metals from industrial sites and pesticides from agriculture, basically it has a lot of health hazards. And some parts of the world, 65% of blood samples taken show DNA mutation. And with globalization and people moving around, it can basically impact, children being born anywhere in the world. So one way that we've been looking at how to sort of make water purification systems which will remove pollutants is to make materials which have a very high porosity. So it's a chemical approach, but you can make these materials shown on the right-hand side there, which have very, very high surface areas. So a lot of porosity means there's a lot of surface, and therefore it can capture a lot of the pollutant. And so here we've basically taken those surfaces and we've attached to them basically a bucket. If you look on the left side, you can see that you can attach these natural kind of chemical buckets. And these can capture, they can target pollutants from water and remove them. So here's just an example with sort of agricultural pesticides. And so first of all, we're just showing this the controls, and then, just a non-woven cloth with the actual sort of a chemical bucket on it, gives very good removal. And the other point to make is you can safely reuse, you can regenerate the cloth many times to remove more agricultural pollutant. So this is actually one of my PhD students, Vera. She went out to India and she went to a leather processing plant. And one of the problems is that in this region, there is a lot of causes of cancer due to chromium pollution from the leather industry. So you can see the water which is coming out is not really very clean. And so what she has done is, again, she's developed this kind of cavity which you can attach onto any kind of material. And then it can be used as a filter to remove these toxic chromium species coming from the industrial leather plant. Yes, so oil water pollution. So quite often there can be oil spillages, and they can even be from, lorries and trucks, leaky tanks. And if it rains, you can get a lot of oil contamination. And as well as sort of damaging nature, it can also contaminate water. So it's important to come up with ways where you can separate oil from water. And so again, thinking about the chemistry, you can basically make surfaces which either repel water or they attract oil. So if you have a surface which can do both, then you can separate them. Make these surfaces which separate oil from water. So basically we have this concept where you can take a mesh and if you have an oil-water mixture, then because of the way the surface is chemically switching very quickly, it can separate the oil from the water. So here we've basically dyed the oil red and the water has been dyed blue. So first of all, this video just shows we have the mesh. We have some oil polluted water. So you can see the oil is sitting on the top, the red oil is sitting there, it's not going through the mesh at all. But the blue water, which we're dispensing, is quite happily going through the oil and being separated through the mesh. So this is a way of separating oil from water. So here we have a dynamic system. So here we've left the water clear and the oil is dyed red. And you can see that the oil has been separated into the second beaker and the water has been separated out into the first beaker. It's gone through the mesh. There's a little bit of oil there, but that can be quite easily removed and just passed over again. So then there is this issue about sort of water. So, especially due to contamination of groundwater, there is a lot of interest in trying to collect water from the air. And so what we've been doing is we've been looking in many countries around the world, in Africa or in Turkey, South America, we've been looking at plants and how plants, even in the desert, if you go to the Sahara Desert, how do plants survive? How do they, without any rainfall, in the Atacama Desert in Peru, how do these plants survive? And if we can study nature, then we can come up with sustainable ways of water collection. And then, for example, you can make meshes on which you can hang to collect water from the air or from the fog. So this was mentioned earlier, this business about the beetle's back. So this beetle lives in Sahara Desert. And basically what it has is a bit like plants. It has hydrophobic or water repelling sort of bumps on its back. And then in between those bumps, it's got hydrophilic or water loving. Sorry, it's got hydrophilic bumps and it's got hydrophobic waxes in between the bumps. So what happens is that on the bumps, the hydrophilic or the water loving area, the water is collected onto the bumps. And then as you can see, when the water droplets get large enough, they basically can roll down because they hit the hydrophobic wax, the area, and they go into the beetle. So obviously you can't use beetles to collect water, but what you can do is you can make meshes. So what we've done here is we've looked at a whole range of different sort of distances between the bumps, and also looked at hydrophilic, hydrophobic, and different patterned areas. And what we've shown is you can make sort of meshes which are super hydrophobic background and a super hydrophilic array, and they collect the most water, as shown on the very bottom bar on that chart there, the bottom chart. And then you can kind of take that forward. So this is a plant called Salsola crassa, which is found in Southwest and Central Asia, Turkey, Ukraine, etc. And so this plant, again, it collects water from the air. So you can see sort of, that middle sort of photograph up there. You can see quite clearly lots of water droplets collecting on the plant. And in the bottom, we've got microscopy images, which show a higher magnification what these, this fibrous structure is. And so what you see is you have this kind of hierarchical kind of almost pasta-like structure. And basically that's where the water is being trapped. So again, we can replicate this. So we can make sort of structures. And what you find is that by having sort of, different length scales, you can get very high levels of water collection. So at the bottom, there's just a bar chart showing that, first of all, on the left of the bottom is the natural plant. So you can see how much water that collects. But then obviously by using technology, we can actually make much better. We can go from sort of 5 to 35 in terms of the amount of water we can collect from the air. And so this is the final example I wanted to talk about, which was to do with, this is a tree which grows in northwestern America in the British Columbia cloud forest. So in particular, what you can see here is that the water is rolling off the branches. It's not going through the branches. And this is important because it means that it allows sunlight to go through the tree branches, but the water doesn't go through. And in fact, a lot of the natural animals like deers and things go and hide under these trees. And this has potential for sustainability because, in many hot countries, including India, there is this huge drive for air conditioning units. And obviously air conditioning units require electricity, which requires fossil fuels. But in theory, especially in areas where there's a lot of rainfall for a very short period of time, if we look at nature, we can basically make roof tiles, which will repel the water when it rains, but allow hot air to escape from buildings. So if we just look at this plant structure in a bit more detail, what you can see is that in the bottom left, we've got a branch of this tree, is that you can actually sketch out the structure. And then what my PhD students did is they thought, well, the idea was, maybe we can actually just make a 3D print a mesh, which is based on those angles. And that's what we've done. So we've made these meshes. And what we find is that, so this has again happened over hundreds of millions of years. The Thuja plicata tree, the angles within the tree branches are so specific that at certain angles, you can see that, you can make the pores very big, 4 or 5 millimeters in size, and you get less than 0.2% of water going through the mesh, purely to do with the angles. There's no chemistry here at all. And also you can tilt, just like tree branches, you can tilt these meshes and the water doesn't go through. So here is an example of one of the 3D printed meshes. And so you can see the water is dripping onto the mesh. The mesh has holes, but the water is not going through the mesh due to the angles of the mesh holes. And so if we bring the camera around, you can see that these from the tree, the angles of the tree mesh, you can see that the water isn't going through at all. But the hot air out of the building would be like you could escape that. And so in the case of where you have maybe not so much a short period of rain, but more lengthy periods of rain, you can actually stagger these meshes. And if you stagger the meshes, then you can stop most of the water from going through the mesh, but you can still get light going through, for example, the solar cells. So here we have the double mesh now. And so now we have like sort of a shower head, and you can see virtually all the water, so the 99 point whatever percent is going through the top mesh. And if any small amount does get through, the bottom mesh will remove it. So again, there's no water going straight through the structure. And then because it's 3D printed, you can use sustainable materials, and you can make roof tiles, etc. Okay, so just finally want to thank sort of many PhD students who've sort of been working on these nature-inspired technologies. And also, we go around the world and we work with local communities, and we sort of learn about sort of local nature, local plants, how they interact with the water. And then we work with those communities to actually come up with solutions sustainable to those particular regions. Okay, thank you very much.
Thank you very much, Professor Pal, for such an interesting and captivating presentation. It is like really in continuation with the previous presentation, we are again learning from nature and talking about how do we really make our science and technology more efficient, and learn how we can evolve better by looking at nature in more closer way. So, there were many interesting things in the talk. Like you talked about making the sieve and how to separate different things. Do we have also a possibility to to separate contaminations like fluoride and other elements, we heard about in previous presentation, using the surface technology?
Yes. So, I think that's where sort of, the bit of sort of science, the chemistry comes in, is that you have to just think about, it's like a hand and glove. You need to design the chemistry to come up with the right kind of glove, which will remove the fluoride. So we know, for example, that in some parts of India, there is a lot of problem with uranium pollution, I understand. So recently we've been looking at, with our collaborators in Turkey, we've been looking at designing these kind of gloves which will remove uranium from water. So that's where the chemistry comes in. But then you also have to look at nature in terms of how to make filters which will remove the pollutant.
Is it also based on the surface structure of water, like really this physical part of it, or? Yes.
So it's a combination of, like with the lotus leaf, when I showed those images, it's a combination of understanding the chemistry and also understanding the structure. And the two work together, because that's how nature has evolved over hundreds of millions of years.
Yeah. So are there some existing tools, like did you develop some kind of portable machine which we can, based on these concepts, can we really develop tools to, let's say, sell this technology further?
So yes, basically we've been making the filters. So for example, I showed my my student there who went out to India and went to a real leather production plant. So we've been making filters, and now we're scaling those up. And then for the water collection, we've made the textiles. And for the also for the all water separation, we've made the meshes. So we just kind of we've done all the science. We've filed patents on many of these technologies, and now we're sort of very much shifting to working with end users in various countries.
Mm-hmm. It's yes, distributing it in different countries as well.
Yes.
Oh, wonderful. We have another question, Professor Pal, for you, from Prince Destiny. He started with thanking you for the great work. He wanted to know if there could be a solution to filter saline groundwater, similar to the one you have developed to separate oil.
Yes, I think it's a matter of, at the end of the day, what you're trying to do is you're trying to stop something going through a mesh and something going through a mesh. So it's a matter of understanding, what the nature of that material is that you want to stop from going through the mesh. And then once you understand that, then conceptually you can come up with, just ways of stopping that. So for example, in the oil water case, we just needed to stop sort of, oil which has a certain chemical composition from going through the mesh.
Yeah. Thank you very much, Professor Pal. I don't see right now any more questions. And this was such an interesting talk. I think this can further be taken, it can be expanded in terms of like what we have as the Live-in Lab, where our students go to different villages and work around the problems and see if they can make some tools or something, so they can learn from your experience, and maybe also the tools and technology they can develop for cleaning contaminated water.
Oh, so, yes, that would be great.
I'm sure that you must have some these works are published, so we can learn from them, and I hope we can reach out to you also if needed.
Yes, it's very much a two-way process, because at the end of the day, we learn from all these different communities around the world about their local nature. And then we help to come up with solutions which will help them to address their problems. So, we can't do it in our ivory towers. We really do have to go out and interact. So it's a win-win situation, really.
Yeah. Okay, thank you so much, Professor Pal. And we will now take a small break, and I think we have to join maybe in 5 minutes, I suppose. So thank you so much for all the speakers and the keynote speakers. I mean, this is wonderful discussion. It was so enriching and fascinating to hear from all of you. Thank you so much, and wish you a wonderful evening or whatever time zone you are. We'll meet again at 6:40. So thank you again.
Thank you.
Thank you, Dr. Alka, for chairing this session. We will now have a brief break, and we will resume again at 6:40 p.m. sharp. In the meantime, I request everyone to fill out the feedback form, which has been shared in the chat.
For over 4 decades, our Chancellor, Shri Mata Amritanandamayi Devi, Amma, has travelled to all 6 continents, addressing and bringing solace to over 50 million people. Her embrace, that began as a sheer expression of compassion, has over the years shaped out to be the largest global drive to create a sustainable future for all. Love and compassion towards all beings are the very foundation of our existence. Amma is the living embodiment of these very values. Amma says, "We are not isolated islands, but are connected to each other like links on a chain, with an unparalleled vision to revive, nurture, and protect nature." Amma has for more than 40 years continuously strived and pioneered various initiatives to restore harmony and embrace sustainability as a way of life. Amma's initiatives are aligned towards achieving the Sustainable Development Goals. As a member organization of the United Nations Billion Tree Campaign, through Amma's initiative called Green Friends, over 1 million trees have been planted across the 6 continents since 2001, Amma has promoted the cultivation and consumption of organically grown vegetables in 101 communities adopted under the Amrita Serve program. Along with this, organic gardens and farming initiatives such as Haritamritam and Growin have been established. To make clean drinking water accessible to one and all, Amma's organization has launched Jeevamritam, a $15.2 million clean drinking water provisioning project for 5,000 villages in India. Along with this, Amma has initiated several programs to provide water access by implementing a number of solutions. Through Amma's Amala Bharatam campaign that started in 2010, more than 7,500 cleanliness drives have been organized by mobilizing 10,000 plus volunteers, clocking over 500,000 hours in 23 states across India. One of the largest drives has been the cleanup of the Holy Pampa River at Shabarimala, which hosts one of the massive religious gatherings in the world annually. The cleanups have been mammoth efforts of 72 hours of hard work of 5,000 plus volunteers from over 12 countries, participating each year, clearing over 2 tons of waste each day. Other key initiatives include awareness drives and distribution of handkerchiefs to school children to promote personal hygiene, design and distribution of banana fiber-based sanitary pads, and a citizen-centric approach to clean the roads across Kerala, with the distribution of 1,000 bicycles and waste bins deployed at 2-kilometer intervals. Amma's organization has donated 1 billion Indian rupees to the Government of India for rejuvenating the river Ganges as a part of the Clean Ganges project. The team has built more than 12,000 toilets with democratic participation. In 2018, Honorable Prime Minister Shri Narendra Modi and UN Secretary Antonio Guterres presented Amma with a special award for making the largest contribution to Swachh Bharat Abhiyan. Amma's organization has been at the forefront in case of natural disasters, providing rapid response and long-term rehabilitation across the globe. This includes serving the victims with real-time medical assistance using the telemedicine unit with a team of volunteers, doctors, and medical equipment as a need of the hour. In the face of tragedies like the earthquakes in Gujarat, Kashmir, Uttarakhand, Philippines, Japan, Haiti, floods in Mumbai, Kerala, and Tamil Nadu, hurricanes in the United States, and the Indian Ocean tsunami, Amma's ashram has provided food, medicine, and temporary shelter, as well as new homes, counseling, and jobs. Using the Amrita Kripa mobile app and a 24-hour call center, 400 plus students worked day and night without sleep and provided relief to more than 100,000 victims during the Kerala floods in 2018 and 2019. Since 2004, Amma has spent more than $75 million in disaster relief. Amma's empathy and concern for disaster survivors is so complete that she responds to every aspect of their emotional and social well-being by keeping an eye on their future. Born out of Amma's vision to empower communities for resilience to climate change and disaster relief, the Amrita Shri program was launched in 2006, with the goal of aiding 500,000 women through the development of self-help groups. With more than 300,000 women currently participating, it provides vocational education, startup capital, marketing assistance, and access to microcredit loans and micro-savings accounts. To provide assistance to people who have been impacted by the pandemic, Amma has rolled out a COVID-19 aid package totaling 850 million Indian rupees. As a part of the second installment, Amma is currently providing financial assistance, grocery kits, and clothes worth 350 million Indian rupees to the self-help group members and to recent flood victims. With a commitment to provide affordable quality care, since opening the doors of Amrita Institute of Medical Sciences and Research Centre in 1998, Amma's organisation has provided more than 6.2 billion Indian rupees worth of charitable medical care, with more than 4.7 million patients receiving free treatment. 100+ free health camps are held every year. Since 1998, Amma's organisation has constructed more than 47,000 houses for the homeless in more than 75 locations across India through Amrita Kutiram, free houses for the poor program. Under the Amrita Nidhi pension scheme, Amma has been providing lifetime pensions for 100,000 beneficiaries, including widows, people with disabilities, and women in poverty. With a resolve to help uplift the well-being of prisoners, Amma has launched a program in collaboration with state and local governments. Instructors have provided training to over 25,000 inmates on Amrita Yoga and I Am, the integrated Amrita meditation technique, in jails across Kerala and Tamil Nadu. Education for a life grounded in intellectual and social responsibility through compassion-driven research forms the founding principle of Amrita Vishwa Vidyapeetham. Unique initiatives in this area include digital literacy, awareness programs using social robots, provides value-based education for impoverished children, skill development with the help of haptic devices, and tribal empowerment. Amma's initiative, called Live in Labs, focuses on experiential learning to provide sustainable solutions to rural India, to bring light and hope to the lives of children who have been impacted by farmers' suicide. Amma has provided various scholarships for education in the state of Kerala, Maharashtra, and Tamil Nadu. With the Vidyamritam Scholarship Scheme, currently 51,000 children from impoverished backgrounds receive a monthly stipend to continue their education. Ayudh, the youth movement founded by Amma, is dedicated to empowering young people to contribute to a peaceful and sustainable world. Currently active in over 50 countries, with 5,000 registered volunteers, Ayudh has initiated several programs to build sustainable practices across communities. The Europe chapter of Ayudh closely works with the UN on several projects and has been recognized by the European Parliament on its 10th anniversary celebrations for its outstanding contributions. The beauty of Amma's initiatives lies in its simple and holistic nature that makes it worthy of emulation. As Amma says, we are all beads strung together on the same thread of love. Let each of us play our part in making sustainability a ubiquitous reality for the future generations to come.
ഒരപേക്ഷയുള്ളത് യൂണിവേഴ്സിറ്റിയിലെ കുഞ്ഞുങ്ങളെ പറ്റുന്ന രീതിയിൽ 2 മാസത്തേക്കെങ്കിലും ഗ്രാമങ്ങളിൽ ഇൻറ്റേൺഷിപ്പിനായിട്ട് അവർ അയക്കണം. അവിടെ പോകുമ്പം തീർച്ചയായിട്ടും പാവപ്പെട്ടവരെ കാണാനും അവരുടെ മനസ്സിലെ കാരുണ്യം ഉണരും. ഇങ്ങനെയുള്ളൊരു ലോകത്തിലുണ്ടെന്ന് ചിന്ത കൂടി അവർക്ക് വരും. അതൊരു സൈക്കോളജിക്കലായിട്ട് നല്ലതാണ്. എല്ലാത്തിലും അടങ്ങിയിരിക്കുന്ന ആത്മാവ് എന്നാണ്. വലത് വെച്ച് വെറുതെ തലോടുന്നത് പോലെ മറ്റുള്ളവരുടെ ദുഃഖം തൻ്റെ ദുഃഖമായും മറ്റുള്ള സന്തോഷം തൻ്റെ സന്തോഷമായി കണ്ട് അവരെ സേവിക്കാനുമുള്ള തത്വമാണ് നമ്മൾ ആധ്യാത്മികപ്പടി ഗ്രഹിക്കുന്നത്.
Welcome back, everyone. The next session and following panel discussion will be chaired by Dr. Soundarajan, who also happens to be one of the program chairs for this symposium. Dr. Soundarajan is an Associate Professor of Water Resource Management at Amrita Vishwa Vidyapeetham, Coimbatore. And his expertise is in the analysis, planning, and management of water resource systems to develop reservoir management and planning tools. He received his PhD in Water Resource Engineering at the Indian Institute of Technology, Madras, and moved to the UK to take up a postdoctoral position at the Hero Watt University, Edinburgh.
But they'll keep
He
me
worked
up.
on
They'll
the
ask me
UK-India
to leave at
Collaborative
1:30. I
Research
can only.
Project. Dr. Soundarajan has worked as a scientist at International Water Management Institute and as an adjunct faculty at Washington State University, USA. His research focus also includes understanding the climate change impacts on water resource availability and the development of mitigation measures through operating policies for water supply reservoirs and developing optimal irrigation scheduling using crop simulations. I invite Dr. Soundarajan to take over from now. Thank you.
Thank you, Harchandra, for the introduction. So this session we have 2 papers, one by Dr. Georgie Orselli, and the second paper is by Dr. Bhavana Arora. And after that, we'll be having a panel discussion. First, we'll be having a talk by Dr. George Orselli. He's an ecologist and works as a professor at ICAM Amazon Regional University in Ecuador, where he directs the National Water Reference Laboratory and the UNESCO Chair on Tropical Freshwater Management. Through his work, he promotes applied research and education at broad levels of society to support nature conservation and improve people's quality of life. He carries out research and training activities with the aim of improving our understanding of ecosystem and natural resources and developing innovative solutions for water use, treatment, and reutilization, together with the policies and the guidelines for the conservation and planning of natural resources. With this introduction, I invite Dr. George to present his keynote talk. Thank you. Dr. George, you can share your screen and start your keynote talk. Dr. George, can you hear me? Looks like Dr. George is muted. He joined, yes.
Hello. Good afternoon. Sorry, my internet connection went off for a second. Can you hear me now?
Yes, we can hear you. Thank you.
Great. Thank you very much. And thanks for your patience. And thank you very much for the invitation. thanks to Rita and Dr. Ramesh and Dr. Manisha for the special invitation. So I like to share some experiences that we had in Ecuador. Maybe you can share the screen. Let's see. Can you see the presentation?
Yes, we can see your presentation. Yes.
Good. So let me just expand this a little bit and I'll start. Well, I'm actually joining you from the World Water Forum in Dakar, and connectivity is a little bit like iffy. That's why I was having some issues, but I'll be talking about these some of our experiences in Ecuador, right? Including a case study where we worked on the coastal area of the country, a small river basin that I think has represents very well. I mean, in many of the things that happen in the whole country. I mean, it's a small at a smaller scale, but I think it shows what happens everywhere else, right? And I think also it might represent some of the things that happen in other river basins in the world, in the tropics and in other regions as well. So let's see. I just wanted to go through, but it doesn't move. I'm not sure if it's the Zoom or something. Hold on a sec, sorry.
3, 2, 1, 0. It's a global shared learning session of an instance of a Latin American Development Bank. And a common concern is finding a curse for innovative financing for water security.
So Microsoft is not responding, it says here.
The double-capped Nigeria's water resources.
Maybe you can close the file and once open it once again.
What happened? Maybe I might need to. Do you mind if I restart or close the program and then restart it? Because it didn't move. Sorry.
3, 2, 1, 0. It's a global shared learning session. It's a global shared learning session of the instance of the Latin American Development Bank. And the common concern is finding a curse for innovative
Maybe I need to stop this for a sec.
The double-capped Nigeria's water resources minister says securing improved funding for the sector is top agenda for the African Ministers' Council on Water, and that too is a priority for Nigeria. The double-capped Nigeria's water resources minister says securing improved funding for the sector is top agenda.
I'll restart the presentation in just a few minutes.
And that too is a priority.
Okay.
Thank you for your patience.
Nigeria's government has demonstrated political will. Nigeria's government has demonstrated political will through the state of emergency declared on the sector in partnership with the private bodies and multilateral agencies. But Suleiman Adamu says, Nigeria, the country needs to strengthen
why it's not starting.
framework through the Water Resources Bill before the National Assembly and also intended to set up the Wash Fund. Also intended to set up the Wash Fund. and for African countries to expand the net for financing of water sector. This panel
I'm not sure if it happens, but like it seems that Zoom interacts with with Microsoft and then create some issues
and for African countries to
because
expand the net for financing of water sector.
it's not
This
letting me
panel
open the
that's very creative
presentation.
with the watch wallet. In Dakar, Muspa, then Wahab, and Sirius.
So if you couldn't open the file, you can also go ahead without the slides. That's also fine.
I think it opened now. Yeah, sorry for it's just kind of too slow.
It's a global.
Yeah, I'll try to share now.
Okay,
It's a
good.
global shared learning session, for instance, of a Latin American Development Bank. The common concern 3210. It's a global shared learning session, for instance, of a Latin American.
This Zoom is not responding. I wonder if it's because of the Wi-Fi that is being used heavily here, or something like that. But I think that's what is happening.
Otherwise, you can also send to us your file. We can project it from here. He left. Hopefully, he will join back now. I'm sorry for the delay. There is a technical glitch from our speaker side. Hopefully, he can join again. Meanwhile, we are also looking for the next speaker. If that is possible, we can have Dr. Georgie can present later. So sorry for the delay. So until Professor Georgie joins, now we have the next speaker with us, Dr. Bhavana Arora. Dr. Bhavana Arora is a research scientist in the Energy Geosciences Division at Lawrence Berkeley National Laboratory. She currently leading a newly launched carbon removal and mineralization program. With a PhD in geosciences from Texas A&M University, her research has focused on advancing predictive understanding of biogeochemical processes in heterogeneous porous media, with the overarching goal of quantifying the impacts of climate and land use changes on ecosystem functioning. With this introduction, I invite Dr. Bhavan Arora to deliver her keynote talk. Thank you.
Thank you so much. I'm trying to screen share. Do you see my slides and hear me okay?
Yes, perfect.
Okay, thank you. Thank you for that nice bio that you have of me. Yeah, I'm glad to be able to present on this. I'm going to be talking about impact of sustainable groundwater management strategies on nitrate loading. So thank you for this opportunity to present. So water scarcity, I mean, why are we even caring about groundwater management issues? Water scarcity is an increasing reality in many parts of the world. As you can imagine, freshwater resources are fairly limited. It's only 2.5% of the total amount of water that we have available. And 97.5% of that water is actually seawater or salt water, which is not fit for human consumption. Well, unless we have desalination capabilities to scale and cost-wise, right? Even among the freshwater sources that we do have, a lot of that is locked up in ice and glaciers, but a big chunk of that is actually groundwater resources. So you might think, you know, that we go out river rafting and we go out close to the lakes. What about those? Surface water actually only contributes to about 0.4% of that freshwater resource. So to sum up, freshwater resources are really finite and limited. And as you can imagine, with the increasing population, more urbanization, industrialization, the demand for that limited freshwater resource is increasing at a much faster pace than the amount that is available in terms of the supply. And climate change is definitely worsening this problem. These are imagery from Lake Shasta prior to and during drought conditions. So the first image that you see here is from November 2011, prior to a 5-year drought that hit California. And then this is from November 2014 at the same site, and you can see the dramatic loss in water that we have seen during these times. And then these are, again, local images from California of Lake Folsom. And you can again see during drought in October 2015, how limited that freshwater resource is, as compared to, you know, we had December 2016, a big rain event, and that lake is again filled up. So, you know, while surface water features, you can see this so obviously that climate change is changing the amount of water that we have. The question is still, what's happening with our groundwater resource? And what is groundwater? So groundwater is the resource that we have. It's kind of a reservoir beneath our feet, you know, that's filled up in the cracks and crevices of soil. So that's groundwater for you. And we do have special type of imagery to even track how groundwater storage may be changing over time. So again, this is showing you California's GRACE imagery, something of a NASA and German mission that occurred between 2002 and 2014. And on the left here, what you see is in June 2002, the groundwater is really green, it's filled up, good quality water out there, good quantity water out there. And then come, in the middle of California's drought, you can see that a lot of that groundwater has been used up. So, groundwater is, again, not invincible to changes that are happening in terms of climate or even human consumption. If we don't have that much surface water available, we're going to tap into our groundwater resources during those drought years. So how does groundwater even recharge? You can imagine that we have these pipes, natural pipes within the Earth's surface at many, many places, which basically are, taking the water on the top and filling it, providing that resource beneath our feet. So it acts like a reservoir that you fill up during really wet years. And you might imagine if it's a dry year, the amount of water that's actually recharging is much low, such that our groundwater levels fall, again, because of climate change, but also because of human consumption that's happening due to a drought year. So, and we've seen this, in California pretty much. So this is a graph that's kind of showing you rainfall, or actually snowpack, for the past decade, every day on December 29 for that same Lake Shasta region that I showed the imagery from. And what's interesting here to follow is that there are a lot of these swings that are happening with our snowpack. We might jump up from 26% to 154% in terms of snowpack that was received by December 29th. But even in the past decade, a lot of these are below normal. So we didn't receive the expected snowpack for each year by December 29th. And again, surface water features are something that are more obvious and visible to us, but the same swings are happening with our groundwater resources, such that their recharge is varying significantly with year to year and with time. So how do we deal with this problem? A potential solution to this is managed aquifer recharge. So humans can help, right? What we can do is we can tap into our surface water resources, especially during wet years, and we can, connect this to our groundwater resource. So create that pipe, so to speak, and mimic the natural recharge that's happening to fill up our groundwater resources over time. So this is intentional flooding, and it's called managed aquifer recharge. And one of the ways that you can do managed aquifer recharge is to do it over croplands or agricultural fields. And this is called AGMAR, or agricultural managed aquifer recharge. So AGMAR is a strategy where you use, again, those surface water or resources to intentionally flood these croplands that will ultimately recharge the underlying groundwater resource. And where's California in all of this? So, California implemented a Sustainable Groundwater Management Act in 2014. And, this came out of a perfect hydrologic storm. So we were emerging after, 5 years of drought that California faced, which meant that less surface water was being delivered to people that needed it the most, and more groundwater was being pumped. And the SIGMA, or the Sustainable Groundwater Management, what they did was they allotted different basins as high, medium, and low priority, which basically means high and medium priority means that the groundwater resource in those basins was really dwindling, and we didn't have enough recharge to support the demand that was going out from those regions. And just to orient you to California, this highlights kind of the Central Valley, which has a lot of high and medium priority basins. And Central Valley is also the ag industry for California and the nation. So California, state policy came into being in 2014, and they really came out and saying that, increasing these groundwater recharge through these management practices, such as MAR or AgMAR, let's use this to become a recognized part of the solution. So they're really pulling through and thinking about sustainable groundwater management practices. Are there others apart from AgMAR? Absolutely. So I just talked about on-farm recharge, but there are other ways to recharge our underlying aquifers and groundwaters. But you can imagine that they have differences in the treatment that's required. As I said before, there could be desalination opportunities, there could be dams and reservoirs. And of course, the cost varies a lot. So the key benefits for AgMAR in particular are that it's a really low cost, low energy water supply option. It's also a natural treatment to replenish those overexploited aquifers. As you can imagine, the Central Valley is this agricultural region, and we do have those groundwater resources that are depleting very fast and are overexploited. An additional benefit of AgMAR is that it does reduce that water runoff loss to oceans. So imagine that we don't tap into the rivers that are flowing out just to the ocean. So they're going to just pick up this debris, and they're going to pick up nitrates and pesticides from our on farms, and they're going to take that to the oceans. So it definitely helps us manage that loss to oceans. It also helps us manage water extremes. As I said before, this is something that might occur in a wetter year as opposed to a drier year. So it's going to help us manage climate extremes that we are seeing so much right now, and also help manage flood. So this is like a natural flood control for using AgMAR as a natural flood control for these systems. It also helps us protect against evaporative losses and algal blooms. So evaporation, because if it's just sitting as a surface water or river water, you might expect more evaporative losses as opposed to if you put that water beneath our ground. Oh, sorry, that's repeated. Yeah, and last but not the least, AgMAR can definitely be scaled up over time. So you can imagine a lot of these on-farm management, happening right next to each other. So it can definitely, scale up to a county, a basin, or a state to provide these benefits of conserving and replenishing our groundwater resources. So what are the outstanding science questions with respect to this? As we said, agricultural lands have all of this like fertilizers that were applied. So what's going to happen, say, when we don't have AgMAR, when we are not applying or flooding our lands, that nitrate is actually going to be taken up by the plants, which is why it was applied as a fertilizer to promote plant growth. But some of that is typically lost to the atmosphere. And, a lot of that is actually left behind in our soils as nitrate. So there is legacy nitrate in a lot of these agricultural settings. So then the question arises, what's going to happen if we start flooding our agricultural sites? Is that going to just push that nitrate that's sitting in our soils to groundwater, or, which is going to worsen our groundwater quality? Because nitrate acts as a contaminant. So it can cause, if you have nitrate in your groundwater, it can cause blue baby syndromes, it can cause different types of cancers. So that's not an ideal situation. So it becomes very important to figure out what's going to happen to that nitrate. So what am I doing in all of this? I'm going to walk you through a few different things. So the first part we want to know is what can we learn from existing data sets about nitrate? What are the existing trends for such agricultural settings? And second, can we use models then to say, are there specific soil types or are there specific regions where AgMAR might be really valuable? And under what conditions can we apply it? And last, can we really, do a sustainable and conscious groundwater management using these new like machine learning or AI-based approaches? So let's start with the first one, which is to look at what are the existing data telling us? So we have, in California, we have USGS wells, which have been collecting nitrate data for as back as the 1960s. And I just wanted to put this picture in front of you, which is showing changes over decades in the mean nitrate concentration in 3 different regions. So some of these Central Valley regions that are closer to the coast versus some of them that are more internal. But the first thing that you can look at here is significant temporal trends for the 3 regions. And some of them are because, our agricultural management practices were really good. So we saw this decline. So fertilizer applications were happening with drip irrigation type of systems. So it was very specific. So we see this decline in nitrate. But we also see for some of the regions an increase in nitrate because there was, as groundwater was depleting, we had seawater intrusion coming in. So there were backflows that were promoting an increase in nitrate concentrations. And then we also looked at the same data, but we put it through a wavelet analysis to mostly look at what is happening in terms of the temporal variability. And this is, wavelet type of approaches. I've used it with Swati Venkatesh from Amrita University last year, a fantastic paper that she wrote for IEEE, different set of study than this one. But again, what this is really telling us is that nitrate concentrations kind of peak every year. So you see this at 12 months, you see these profiles, but there are gaps in when that peak is not happening. And that's typically related to whenever we had a drought event. So, if it's a wet year, you're going to see higher nitrate concentrations in the groundwater as opposed to if it's a dry year. So what does that mean? It's kind of suggesting the opposite, that if we now start flooding our croplands intentionally using these AgMAR applications, that's actually going to exacerbate our nitrate problem, especially in groundwater. So coming to part 2, which is applying a model to ask these questions. So our site here, again, focusing on that Central Valley location. This is a field site in Modesto in California. And you can see we've flooded the field during winters when there isn't much crop application or much crop growth happening in an almond field site. And, as I said before, Central Valley is really, a $46 billion industry for our particular region. It's the agricultural capital for California and the nation. So here, the groundwater table is really deep. It's 10 to 15 meters. The sand is fine sandy loam. And what we did was, the first question that we asked was, are there different soil types where we could apply AgMAR and not pollute or not leach a lot of that nitrate that's been sitting there, as a legacy of this being an agricultural site. So we conducted or we created these 5, model domains, going from like homogeneous sandy loam, silt loam to, more complex soil configurations. And these were based on the data that we had from our site, which was, we had, this is an ERT profile of our field, which basically shows you have, this is more coarse, so there's much faster flow paths happening here, as opposed to, the finer layers. So this kind of looks like a sand with a loam channel in between. And then this one kind of looks like a silt column with loam channel in between. And then to capture the entirety of that flow domain, you can see, higher flow paths here, or sorry, lower flow paths here, and then, a higher zone in the middle, which is what we created in our fifth column. So a preferential flow path in the middle, and then 2 clay type of lenses on the side. And then the second question that we asked was more operationalizing AgMark. Do we apply it under drier conditions or when it's really wet? So what should be our background moisture conditions, and what would be the impact on the nitrogen biogeochemistry? And last but not the least, we also asked the question, what would make more sense if we applied all of that flooded water at once? So say we had 60 centimeters of water available to us. Do we apply all of that one-time application? Do we break it up into one application per week for 4 weeks? Or do we do this bi-weekly? So have twice the amount of application 2 weeks for 2 weeks. So what is that duration, frequency, and amount that's going to reduce our nitrate transport to groundwater? And we used a geochemical model to do this. And, not to complicate things, but what we're looking at is how that nitrate can be denitrified to lesser contaminant properties, or is it going to be used up in some form to actually, if you have iron minerals or sulfide minerals in your soils, which are typical for agricultural settings, is it going to get reduced but have more cycling of these iron and sulfide minerals? So those were the type of questions that we asked. So what are we seeing from our modeling results? We, as I showed you, we had 2D transects for those different soil types and configurations. And we ran the simulations for over 100 years to come to a steady state from our profiles, and then ran them for 60 days to implement our AgMar scenarios. So what you can take away from this is A, F, and K represent the homogeneous sandy loam. This is C, H, and M are this homogeneous silt loam. And then, this is showing you the sandy loam with the silt loam with the sandy channel, and the preferential flow path. But this last one is showing you nitrate concentrations after flooding. So what you're seeing here is basically for that homogeneous sand layer, our nitrate is pretty deep. It's actually hitting that groundwater table that we set at 15-meter depth. But if you compare that to our homogeneous silt loam, our nitrate is still stuck in the vadose zone. So we haven't leached it far enough. The other thing that comes to mind is, when you have that sandy loam, the faster flowing flow path, and you put a silt loam channel in between, you are preventing the transport through that small channel itself. And see the opposite, if you have the silt loam channel, if you have the silt loam channel, but the sandy loam in between, you're still, promoting the transport much, much faster through that sandy loam channel. So the first result here is, of course, if you have those clay or fine texture soils, either alone, like that's your homogeneous agricultural setting, or if you have them as lenses or channels, they are important to prevent that nitrate leaching from happening. But on the other hand, say if you have these preferential flow paths or coarser textured soils, they're promoting that nitrate to go much faster, much deeper into the groundwater. So this is, saying what's happening really in those fine textured soils. Why are they preventing the flow? Apart from the texture themselves, that you have these, finer particles that create those reducing conditions. What we also saw was for those silty loam soil columns, there was lower carbon. And as you can see from the pH profiles, just comparing the sandy loam with the silty loam, the pH itself was much lower as compared to what you see in the sandy loam columns. And we also saw iron profiles being different, so much higher here. And that's really because a lot of that nitrate is promoting chemolithoautrophy. So it is getting denitrified in these fine textured soil columns. And they're perhaps more dominant than other microbial reductions that are happening in these columns. And then, as I said before, to operationalize AgMAR, we also looked at what is going to happen, if we had a wetter field when we apply these conditions. What we see here is that with a wetter moisture condition, we will get greater transport, so you have soils that are already wet. If you apply more flooding on top of that as part of AgMAR, it's going to promote that nitrate transport much deeper into the soils. So you can see, here, the amount of nitrate that's within, in the deeper beta zone is much, much higher under the wetter or the green conditions, as opposed to 15 to 20% less moisture conditions. But again, under S1, where you apply all the water at once, if you look at the 150 centimeters, we actually get much greater denitrification, which means that you can figure out how much water we should apply, so we promote more denitrification in situ nitrogen retention as opposed to leaching. And this is kind of summarizing that result that I just said. So this is showing you the amount of nitrogen that gets denitrified, and under all conditions, S1 is the red one. We see the highest amount of denitrification rates when you apply all of that water at once. But if you apply it, in breaks, what's happening is you're introducing oxygen in your system, and that nitrogen actually gets nitrified. So it gets converted back to nitrate, and then there's the opportunity to leach more nitrogen into your groundwater. So, modeling really offers us the possibility to explore these interactions, especially with the microbial pathways. And, we've published this work in WRR. I'm happy to share this paper with all of you. But I just want to summarize what we did here. So we definitely, were able to quantify how AgMAR application choices work with your local site conditions and your moisture conditions, and how much can they influence the leaching of nitrate. What we found was through those model simulations that these finer textured sediments, such as silt loams, they are really important reducing zones that are going to prevent the leaching of nitrate to deeper groundwater. And then we also found that applying water all at once in large amounts is a much better strategy than breaking it up into smaller fractions, because that's going to increase your nitrate leaching. And again, just to emphasize that for each site and for each local conditions, this is going to be unique. So we can design those ideal rates. I just want to put this also in front of you. So the last thing that I said we're going to discuss here is, can we use machine learning or AI-based approaches to actually just predict what's happening with your groundwater? So again, focusing on the California region, we took data from 2016 to 2018, from 2011 to 2015, we took daily data and we used different types of machine learning algorithms, and we trained them, and we were able to predict daily groundwater levels from 2016 to 2018 using these approaches. So, what is that groundwater going to look like if those same situations continue? But we also account for climatic parameters. So we also did a sensitivity analysis for machine learning algorithms to say what should be your input parameters. And again, this work has been published, and I'm happy to share those papers with you. So with that, I want to say thank you, acknowledge my co-authors here, and I would be happy to take any questions you might have.
Yeah. Thank you, Dr. Bhavana, for a very interesting presentation. It's really very interesting work. I think we are running short of time, so I also couldn't see any questions here right now. I have one small question here. When we have the AGMER, that is Agriculture Managed Aquifer Recharge, will there be any issues to the crops? So here we are, I think my understanding is that we are irrigating more than the crop water requirement in order to recharge the aquifer. So will it affect the crop yield, growth, or development in any way?
Yeah, that's a really good question. That's something we're also looking at. That are there certain types of crops that are more amenable to Agmar type of application. So this one was for an almond field site, and we did it only in winter. So, that snowpack or the river, if we didn't tap into that, that was just going to the oceans. So it was lost water. So it made sense to do it at that time. But we are definitely, exploring, say for rice, it does make sense where you have those ponding conditions, but it does depend a lot on the type of crop type as well. So still a work in progress, I want to say.
Okay. Thanks a lot. Thanks a lot for your interesting work. We have seen the interesting papers as well from WRR. We'll go through that and then we will get in touch with you once if we have any issues with that. Thanks a lot. Thank you very much. So next we move to our previous speaker, Dr. George. So he will present now, and then so shall we make his presentations little short so that we can move to our panel discussion on time. Thank you, Dr. George. Thank you for joining again, and please go ahead.
Thank you very much for your patience, and sorry for the issues with the connection. Let's see if it works now. I hope we don't have issues. Let me know if you can see.
Yes. Okay. Your slide is visible. Please go ahead.
Okay. So what I'd like to present today is something that is a little bit general, and it's not that specific as the former presentations, which were wonderful. But at the end, I'll share some more specific cases study that we conducted here of one study that we conducted here in Ecuador. So I'll talk a little bit about Ecuador's climate, water resources in general, also aquatic ecosystems and ecosystem services, and some of the threats and economic activities that affect these ecosystems, and how vulnerable are ecosystems to different scenarios, and then through the discussion of this case that I mentioned, I'd like to discuss about challenges and opportunities. So I'm not sure if you're familiar with Ecuador, but it is right on the northern part of South America, on the Pacific Ocean, and we do have 4 different regions: the Galapagos Islands, the coastal region, which includes this small range as well, that goes from the ocean to 800 meters of elevation, and then the Andes that go up to 6,000 meters or so, and then we are in the headwaters of the Amazon as well, on the eastern part of the country. And Ecuador is a very small country, and also is the most densely populated country in South America. So you can imagine what is happening there, right? Water resources are diverse as well, and they are linked to the geography of the country. I mean, as I mentioned, we have the Andes, and also we have the cold Humboldt current that comes from the south and cools down and dries the coastal area, right? So we do have very arid areas in the coastal part of Ecuador, in the southern part of Ecuador, and some arid regions as well in the highlands, and then a lot of variety in climates and ecosystems that are related to that. So you see the northern part of the country is very humid, towards the coast as well, and then the Amazon region is very, very humid. So temperatures are also very variable. I mean, they go from snow-capped mountains and very cold temperatures up to the rainforest. So because of that, actually, because of this variability, we do have a lot of water resources, but also they are not evenly distributed. And as you can see, we have a lot of resources. Most of them are used for agricultural purposes. About 90% of the population in cities and 75% of the population in rural areas have access to drinking water. So it's not a huge issue as in other parts of the world, but but still, this is becoming an issue, a bigger issue nowadays, actually, because of scarcity and contamination, and that also is in part related to the industrial activities, agricultural activities, but because water is not treated. I mean, only 3% or so of water is treated in the country. But well, and going back to like the variability of climate, you see that creates a lot of variability in ecosystems, of aquatic ecosystems in particular. I mean, all kinds actually, but like I wanted to show you some of the aquatic ecosystems of the country. You see, like we have like a lot of water in the highlands and the Amazon region, and then like a more drier areas in the Galapagos Islands and in some parts in the coastal area, the southern part of the coastal area of Ecuador. And these ecosystems are very important actually because they do provide plenty of ecosystem services. I mean, there's vegetation that like riparian vegetation that prevents flooding or actually protects the land from flooding. A lot of wetlands that process nutrients and organic matter, and there's like a lot of sources of water. Like people rely on rivers and springs for water provisioning for human consumption, and we do have plenty of dams nowadays that provide most of our electricity. I think 97% of our electricity comes from hydropower. But these ecosystems actually give us like food and recreation and different cultural ecosystem services as well. And well, Ecuador has been since like the 30s, for instance, that we were like exporting like cocoa beans and coffee, with being an agricultural country. And then in the 50s, actually, like we started, like we had a boom on the banana plantations, and nowadays Ecuador is like one of the main producers of banana in the world. So you can imagine the whole or a lot of the coastal plain is converted to banana plantations. And then many mangroves, for instance, mangrove forests have been converted to shrimp farms, but also to palm. A lot of the land actually has been converted to oil palm plantations. So that is happening mostly in the coast, but also in some regions in the Amazon. We have like big palm plantations, and in the Amazon since the 70s we have been extracting oil. I mean, and that has had a lot of created a lot of issues in the aquatic ecosystems, a lot of pollution problems and effects on the environment. And nowadays also, well, lately actually said during the last decades we accelerated like with the dam construction, so we have plenty of dams nowadays as well in the Amazon especially, although also on the coastal region. Lately, we had a lot of illegal mining. This just happened the last year and this year, very close to where we actually are in Tena in the Amazon. They are like damaging a branch of this river, the Napo River. Also in the highlands, I mean, a lot of the agricultural areas have been converted to like plantations, like flower plantations, for instance, with like potential issues on the environment as well. And still we have these traditional economic activities like cocoa and coffee. Nowadays also we do have like more community tourism, and rafting and kayaking is a huge thing as well in some rivers in the Amazon. So and as I mentioned as well, like mining is becoming huge. I mean, like the country is investing a lot in mining, or like promoting mining, with mostly like large scale mining, although we do have illegal mining that is a lower scale, which I think is actually more damaging. But a lot of like many regions like from on both sides of the Andes are being affected by mining. Um, so just to give you more like an overview of what is happening in the Amazon region as an example, this is more or less how the Amazon region looks like. It has a lot of roads now, that have been built after like oil oil extraction and expansion of agricultural lands. Like most of the Amazon has been like parcel or like separated into like oil fields as well. And as I mentioned before, mining is becoming a big thing. And dams, you see dams, there's a lot of dams being built or that have been already built during the last decades. We do have like plans to build about like 150 dams in the country, and I hope that doesn't occur actually, because it's unnecessary and it's very damaging for the environment. And a lot of the landscape as well is protected. I mean, it's under protected areas, and but it's still not like a lot compared to like the levels of diversity that we have. I mean, these are some big protected areas that are in the Amazon. In the coastal areas, we don't have a lot of protected areas, and they are also at risk actually, because they are surrounded by human activities, and some of these activities are encroaching into the protected areas. So this is more or less the level of risk that we have in the Amazon as well. Like you see, in darker colors is the areas that are more vulnerable, more susceptible to changes, to impacts due to human activities, and that also is having an effect on like a positive feedback on people, right? So there's these levels of vulnerability as well that occur at different levels in the Amazon among people. So so that's more or less to give you an idea of how Ecuador works in terms of, or what is the situation of Ecuador in terms of human activities and the interaction with aquatic ecosystems. But also I wanted to mention a little bit about like the legal and institutional framework that is behind this, right? So Ecuador has one of the first constitutions that gives rights to nature, right? And we do have a water law as well that I mean is fairly good, although it's not applied actually. So in some ways, and we still don't enforce enough the law, and there's also some glitches, if you want to say, with the law, right? So there's some conflicts that need to be resolved. But according to the constitution and the law, like all of the state and the whole population actually is supposed to conserve aquatic resources and allow it to persist, right? And there is the Ministry of the Environment and Water are the ones that are in charge of supervising that. Some of the things that the law actually said are that we're banned from hoarding. Privatization is banned as well, and the order of the priority order for water uses are first human consumption, followed by irrigation, and in the third place is the ecological flow, or the needs of the ecosystem, and in the fourth place are productive activities, including the industry in general. So we think that there is an issue here in this priority order, and we think that the ecosystem should be the one that is first, because it's the one that provides for the resources, right, to people. So, and also how it operates, it goes from like the ministries to like the local levels, the local governments, and eventually to we're supposed to be organized, I mean, among water boards, and which are not working well yet. I mean, they have been trying to implement them since the last decade, but in some places they worked, in other ones they haven't. And actually at the lowest level, it seems is one of the levels that work the best. I mean, like at the lowest level would be like at the parish level, more or less. So we actually worked with like a parish, and I'll show you later on the work that we did together with them. What else? And let's see. Well, we are like aligned to like the sustainable development goals, but of course everything is like in paper, right? And some of the things that still don't work very well. For instance, we do think that we need to like revise, as I mentioned before, the order of water uses, the priority order, and then there's also some laws like the mining law, some land uses law that conflict with the water laws as well. So we do need to like figure out what are those conflicts and minimize those. And same with the actual uses, right? With land uses and water uses and the different types of water uses. I mean, if like the human is in the first order, I mean, like they should have like the first right instead of electricity, for instance. But like sometimes the government says no, electricity is a priority, and then like the people has to suffer because of that. And the same, the environment, right? The environment actually is in practicality is in the lower level. So we definitely need to work on improving our regulations and enforcing them, and also to work on education and capacity building at all levels, including like the different levels of government and the society in general, and the same with the governance, right? So I'd like to mention this case study of the Muchacho River Basin, which is a little watershed in the coastal region of Ecuador. Is very small, but it is a very interesting case because it shows, I mean, all of the things that happen in, I mean, I consider that it's a good example of what happens in the country, right? And so the Muchacho River Basin is right here in this area of Ecuador that is right on the transition between the humid forest of the north and the drier ecosystems of the south. And it has a lot of issues. I mean, it's not, I would say they're very bad actually for the scale. Like a lot of husbandry practices and like roads that are like poorly built and that cross rivers, and bad agricultural practices, and like cows, for instance, go into the river and poop right on the river. And also, they use a lot of pesticides. They obtain most of the water for irrigation from the river. So the uplands maintain some of the water, but like the lowlands are almost dry because of the pumping, right? Because of the irrigation. And as you see here, I mean, it has a fair amount of rain during some time of the year, and then eventually it gets very dry. So it's very seasonal, and that's a big issue in the basin because there's a lot of people living there, and with doing a lot of agricultural activities that need water resources. So there's a deficit of 250 millimeters throughout the year, and also evaporation exceeds the threshold as well of 50 millimeters per month. So especially during the dry season, right? And as you see, the river flows are about like 5 to 36 liters per second between the dry and the wet season. So we conducted these climate change scenarios, and here you can see how climate is precipitation and temperature actually would change. I mean, are changing until now, and then how we expect them to change. So we expect to have less precipitation in general in the whole province, actually including the Muchacho River Basin, and higher temperatures. So that would like imply that we won't have enough water resources for the future, right? And if population growth continues going high or up, that is going to be a big problem. So maybe I should move a little bit further. So we also assess how land use changed during the last decade or so, and you see like in less than a decade, actually, like almost like let me see, like 20% of the forest that remain at the time in 2013 is gone. I mean, it's like actually it's more than that. I think it's almost like, if you see the green thing here over here compared to this over here, it's almost 50%, right? Of the original forest, and then everything is being converted to grasslands and plantations. So, and people don't understand why they don't have enough water. I mean, it seems obvious, but people don't understand. Some of the drivers that are that from this assessment that we conducted are like, for instance, of deforestation are the relationship with towns and roads, and also the location, some features of the landscape like the slope and the elevation. I guess like the steeper probably is more protected, and the flatter is more vulnerable, right? And also the proximity to rivers and so on. So we do know that there's a significant reduction in the native forest, and also, for instance, 80% of the headwaters are used for livestock activities. The good thing is, I mean, we are like planning some water conservation areas. I mean, it's easy to plan as well, but then we do need to like work with the communities and convince them that they are very important, right? And a good thing is that like some of them actually are willing to improve management practices, like livestock management practices, for instance. And definitely restoration of riparian areas or other areas as well need to be implemented. I mean, it's a big opportunity to start restoring the watershed and improving the health of the ecosystem. And now I'd like to talk about a bit about this work that we conducted. It was the initial work, this biophysical assessment of the watershed that helped us kind of diagnose what was happening here, and then figure out what needed to be done, right? So here you can see some physical chemical parameters that we measured, including fecal coliforms as well. And many of these parameters exceeded the thresholds for like the Ecuadorian, American, Canadian regulations. So using this line of evidence, we definitely were able to tell that like the headwater, or the basin actually was not in good shape. Temperatures, for instance, increase downstream because of the increase in deforestation. There was a huge increase in the dissolved organic carbon as well in the river, and actually this exceeded like concentrations of other coastal basins by 3-4 times, right? And actually there's not a lot of forest left, as you were able to see. So that's not the main source of the DOC. It's actual manure and things like that from animals, right? From animal husbandry, from husbandry practices. And also that was the reason why we exceeded on the microbial contamination with the fecal coliforms. Likewise, it happened with ions, and although some of them were fine based on the regulations, but some ions like lithium, bromide, and fluoride, chloride were higher than usual. We thought that they might be related to agricultural pollution, but definitely the nutrients, right? Like the main nutrients like nitrates and ammonia, and those definitely were linked to some of the agricultural activities. And levels of pesticides were like very high. I mean, some of them were even above the permitted levels in the country, and some actually were banned in the country. Like I think is parathion that we were not supposed to have in the country, but we did find it. So I think it was like in some places, some of the levels were up to like 25 times the threshold levels. And we did also assess macroinvertebrate biodiversity, and we found mostly, relatively few indicators of good water quality. And most of the other families that we found were indicators of poor environmental quality. So that is telling us that the ecosystem is not working very well. These rivers should have other groups of animals, more abundant indicators, or groups of that are indicators of good water quality. And I think this is because there's not enough oxygen. The oxygen is being consumed by all these nutrients, organic matter that is being released, and all the higher temperature and the low water levels, right? As you saw in the pictures, there's a lot of eutrophication going on as well along the creek. What else? Also, probably levels of pesticides as well are affecting biodiversity, right? So we did conduct these phytotoxicity tests, and here is the control, like the headwaters, and you see like plants were able to grow better in the under the water conditions in the uplands than in the lower parts of the basin. Although when we did this assessment with sediments, they did grow better in the lower parts, and we think it's because of the amount of nutrients that the plants had that allowed them to grow higher. But overall, when we combine all of these lines of evidence, we did assess the health of the whole ecosystem and concluded that is not doing well. It's in very bad shape. And some of the reasons, as you can tell here, are like these pollutants, the deforestation, the erosion that is causing is filling in the river with sediments. So habitat diversity is also being lowered, and also the water extraction is also having a big effect on the ecosystem. There's not enough water for aquatic invertebrates or vertebrates as well. What else? And yeah, those were some of the things, right? Like here you can see these are the points in the lower part of the basin. These are towards the middle, and these are in the headwaters.
Okay,
So,
Dr. Jay, we have 5 more minutes.
5 more minutes? Yeah.
Yes.
Okay. I think I'm close. Maybe. Well, so I guess you have an idea of what is happening there, and just wanted to mention also that like people, despite these problems, they use the water for like irrigation, for human consumption, and we did do these interviews, and they also are being already affected by the quality of water. They had issues, health issues. And because they're like using the water for irrigation, they probably eat the fruits, the vegetables that are being contaminated, and also drink water from the river, right? So we thought that this basin would could be a good example for other river basins in the coastal plain of Ecuador and other regions of Ecuador as well, to improve management, right? Like water resources management, land use management. But we, for instance, needed more eco-hydrological monitoring. We do definitely need to do some land planning, and there's some opportunities for that. To do land planning, conservation, and restoration. And we like to implement continue monitoring the aquatic ecosystem to see if these activities work. The community is actually building a water plant for human consumption, but also they will need like a treatment plant for like wastewater. And since it's in a very dry area or like a seasonal area, definitely we need to find other alternatives to find more water, like not just the river, right? Maybe the river is going to provide more water if it's being restored and the land use changes and there's more conservation practices. But there's some ancient technologies, for instance, that have been implemented in the coastal plain that help collect water. There are some small earth dams that collect water, recharge the aquifer, and then provide improve like the whole water cycle actually in these small basins. So maybe something like that, and maybe use meshes like to collect water from coming from the ocean, right? Like with from the fog coming from the ocean, and also be more efficient at the water uses. So just to summarize, I think it is very important to revise the order of uses of water resources in the country. As I mentioned before, minimize the conflicts between laws, improve regulations, and enforce them. I mean, like people do whatever they want, basically, right? And despite there's a law that forbids to cut the riparian forest, they go right to the river and put plantations right by the river and cut the vegetation that is very important by the rivers. I mean, because they control nutrient sediments and also maintain water, right? So we do need to minimize conflicts between land and water uses and the different water uses as well. Improve planning and the efficiency and standards for agricultural practices. I definitely think that agricultural activities cannot be as they've been until now. I mean, like monocultures are not good for the environment. I mean, we do need to start like growing more agro forestry systems, right? Like had like food forests, for instance, and they had better standards as well. Avoid using pesticides, and there's alternatives. I mean, it's not impossible, right? So I think the financing also is important in this, and the markets are very important as well to facilitate these processes, but also education, capacity building, and improve governance at all levels, right? Like I think, the academy schools they know very well what needs to be done, but they need to work with the communities and the governments and try to improve like management in the country. That's it, I think, what I had. And I wanted to mention actually that this assessment was conducted with through a course at the school where I worked at IKEM. And most of the work has been done by the students, the water sciences engineering students. So I'm proud to share this experience that we developed with them, and I'm open to have any questions as well. Thank you very much for your attention.
Thank you, Dr. James, for the very excellent presentation. There's one quick question from my side. So when you are building a large water resources projects like dams, so one of the least priority is ecosystem services. So they give more priority to the other water demands like water supply to the cities, industries, hydropower generation, and irrigation. So what is the situation in Ecuador when it comes to the ecosystem services? Because most of the developing countries, we are still not bothered to provide sufficient attention to the ecosystem services. Thank you.
I guess I hope I understood well, but I mean, dams are I think they're important as well, right? Because they do provide hydroelectricity and is relatively cleaner energy than other types of energy, right? So we have had dams like forever, and like historically there's been dams everywhere in the world. In Ecuador we have dams like since the last century, if you want to say. Some are located in the Andes, for instance, in the foothills of the Andes, or like in the uplands actually, where like there's not a lot of issues with the connectivity, like between the lowlands and the uplands, because they are already there are geographical barriers. So, for instance, having a dam there, I think is not too bad. I mean, because it doesn't affect too much the connectivity of the ecosystem. But then having dams like in the lower part of the basins, they might have a bigger effect, right? So that's one thing. And then damming all of the rivers, that is not possible. So well, I mean, and that's what like our water resources program actually is promoting, like our water resources plan is promoting to develop all of the rivers and put dams for flood control, for electricity, for irrigation, for everything, right? So it's changing how the water cycle works in the country. But also they retain sediments and nutrients that are important in the lower parts of the basin, and one of the most important things I think it is also like that they affect the connectivity, and especially those towards the lower parts of the basin. And then affecting the connectivity would affect all of these fisheries, these migratory species of fish that come from either the Atlantic or the Pacific to the foothills to lay their eggs. I mean, and then I mean those fishes wouldn't be able to arrive to the Andes to do that, right? So then that would have a positive effect towards a positive feedback actually, and a negative effect on the populations of these animals that a lot of people rely on. I mean, so I think what needs to be done is to just pick some places for like dams and allow other rivers to maintain free, I mean flow free, so they can keep continue with these ecological processes that are very important for the provision of ecosystem services in the country. I'm not sure if I answered completely what you
asked. That's great. Yeah, thank you. Yeah. Thanks a lot for your elaborate answer also. Thank you all for attending this session. Next, we are moving to the panel discussion. Let me see whether I can able to share my screen. Okay. Yeah. Hope you can able to see my slide.
Yes, sir.
Yes. Thank you. Thanks a lot. So now we have a panel discussion on achieving sustainable development goals in water. So here we are going to focus on lessons learned, societal challenges, and the technological opportunities. The sustainable goals are global goals adopted by the UN. All the UN member states to improve life for all people in the world and to protect the planet. This is the basic idea. There are 17 goals. One among them is about water. So this session is focused on achieving sustainable development goals in water, lessons learned, societal challenges, and technological opportunities. So if you look at it, what is the goal? So the goal is about providing clean water and sanitation. So this is the goal here, to ensure access to safe water sources and sanitation for all. So it has number of targets. So you know that there are a lot of water issues globally. To overcome them, so all the United Nations member states come up with one goal for water. So you can see that there are 6 plus 2, there are 8 targets that needs to be achieved in 2030, in around 8 years time from now. So there are, as I mentioned, there are 8 targets. One is, you can see that 6.1 is all about achieving universal and equitable access to safe and affordable drinking water for all. 6.2 is adequate and equitable sanitation and hygiene. 6.3 is improving water quality by reducing pollution. And 6.4 is about increasing the water use efficiency across all sectors. And 6.5 is about implementing integrated water resources management at all levels. And then 6.6 is about protect and restore water-related ecosystems. And also we have 2 more targets, that is 6A and 6B. 6A is about expand international cooperation and capacity building, especially for developing countries in water and sanitation. And 6B is support and strengthen the participation of local communities in improving the water and sanitation participatory management. So these are all the targets that we need to achieve by 2030. So what we want to focus in this discussion. So we have to focus on what has been achieved so far in SDG 6. The next one is what lessons we have learned so far in, and then third in what are the challenges in achieving the SDG 6 in the coming years, and then fourth one is what are the opportunities available for technology. So in the technology advancement in the other sectors or the other domains can play a key part even in water or achieving the sustainable development goal in water. And finally, what we can do as a common man in achieving the SDG 6. So we have panelists, distinguished panelists. We have 6 panelists here, so from different domains. First, we have Ms. Anjali Makija. She is a Chief Operating Officer at the SM Seagull Foundation. So Anjali Makija has over 25 years of experience in the area of rural development, women empowerment, and governance. In the past 2 years, she has been involved in organizational development by leading the core group and management team at Seagull Foundation. She plays a key role in strategic building, sustainable growth, and the people management at Seagull Foundation. So Ms. Anjali holds a master's degree in social work from Delhi University and a bachelor's degree in economics. She is a member of the advisory committee and outreach program of Maharishi Dayananda University. She was a former chairperson of the General Committee of Seagull Foundation during 2013 to 15. I welcome you, ma'am, for this panel discussion. And next we have Mr. Jeevan K. Raj, who is a managing director of GenX Utility Management Private Limited. So Jeevan Raj is the founder and managing director, and he is the patron of Red is Blood Kerala. This is an NGO. This is Red is Blood Kerala RIBK. So he is taking care of Bangalore unit. So this RIBK is a blood donation and charitable organization that was formed in the state of Kerala to help the society by providing non-profit blood donation services and social services. So the organization currently operates in Kerala, Bangalore, and Malaysia. It has helped thousands of people in blood emergencies and saving many lives. So during the pandemic also, this RIBK donated blood, and also along with this, they also distribute thousands of masks, even sanitizers to the public through the government departments. I welcome Mr. Jeevan K. Raj for this panel discussion. Third, we have Dr. Dakshinamurthy Ramu, who is the Global Contact Point Human Rights and Climate Change, Children and Youth Constituency to United Nations Framework Convention on Climate Change. He is an NGO. So Dr. Dakshinamurthy, an eminent youth leader of India and founder and General Secretary of the International Youth Forum and the Sustainable Development Council, who also represented India multiple times in the UN headquarters. He volunteered with international entities like the UN, Commonwealth, etc. For the past few years, he also found 2 national and 1 international organization. Dr. Ramu has been awarded Karmveera Chakra Bharat Jyoti Award and several international awards for his work towards empowerment of youth. I welcome you, sir, for this panel discussion. And we have 4 panel members, Dr. Sanjay Paul, who is Associate Professor at School of Biotechnology, Amrita Vishwavidyapith. So Dr. Sanjay received his PhD in plant biotechnology from IIT Kharagpur, and done his postdoctoral training at the University of Texas Health Science Center at San Antonio and matrix biology. So Dr. Sanjay's current interest lies in the application of matrix binding bacteriophages and biocontrol agents in sanitation. His research group is funded by both national and international funding agencies. They are highly respected funding agencies like Gates Foundation, Department of Biotechnology, etc. Then we have Dr. Vishwanathan PK, Professor, Department of Management, Amrita Vishwavidyapith. So Dr. Vishwanathan serves as a professor of economics with specialist interest in the economics of natural resources management and sustainability. His research and teaching interests are related to economics of natural resource management, agrarian transformation and rural livelihoods, aspects of technology, institution, policy and governance, climate change impacts on natural resources. I welcome you, sir. So then we have our Dr. George R. Silly, Chairperson, UNESCO Chair on Tropical Freshwater Management, University of Regional Amazon, EPM. So I welcome you, I welcome all the distinguished panelists for this panel discussion on achieving sustainable development goal in water, lessons learned, societal challenges, and technological opportunities. So there will be 5 minutes for each panelist to express their views about this panel, the topic. And then after that, we can take questions and we can go for the discussion. First, I invite Dr. Anjali Magija for your views. Thank you.
Thank you so much, Dr. Sundarajan. So I would just like to first reflect on a couple of factual information which I wanted to share. I am from Sehgal Foundation and we work at the micro level in the rural areas, in the villages. So my comments are based on my experiences in the rural areas. Just a couple of factual information. According to World Bank, India is now the largest user of groundwater worldwide, pumping out 25% of all groundwater extracted in the world. And more than half of India's districts are threatened by groundwater depletion or contamination. In the past sessions, we have all talked about groundwater depletion, but this is something which I want to flag because it is very closely linked to the agriculture sector and water efficient agricultures, which is very much relevant for the rural areas. Another fact which I would like to share is, according to UN, at least 892 million people continue to practice open defecation. Since water and sanitation, these are the two things which we talk about in SDG 6. And so I would specifically mention about defecation. And the third point is about gender issues related to water and sanitation. Women and girls are responsible for water collection in 80% of households who have no excess of water in that premises. So this is a gender dimension which is very much rampant in the rural areas. In 1950, India had 3,000 to 4,000 cubic meters of water per person, which came down to only 1,000 cubic meter in 2019, according to World Bank. So this is a few facts. Given this background, I want to flag 4 points here. One is, of course, the depleting groundwater, and closely linked to it is the cropping patterns, which are linked to the depleting groundwater. And Sehgal Foundation is doing a lot of work in harvesting water. There is an important dimension of artificial recharging, and recharging has to be more than the extraction. And water efficient agricultural practices such as drip and micro irrigation is something which we are promoting, building a lot of check dams to arrest the water which continuously, is wasted. And I'm not talking about rivers, but water which just flows outside the villages. So a lot of work on depleting, recharging groundwater. The second aspect I want to mention is about scarcity and access of water at a household level. And Government of India has started Har Ghar Jal campaign to ensure 100% households with tap connection. And the National Water Policy of 2012 also, where the center, states and local bodies have to ensure access to minimum quality of potable water and essential health and hygiene to all citizens in India. So of course, scarcity and access is important, but so is the issue of contamination and pollution. And we are also developing technologies, because this session is about technologies, a very low cost biosand filter and Marticulp to address especially arsenic, iron, and biological contamination. So if there is more time, you can visit our website and look at it. The third point I want to flag is about role of women in water management. And as you know, women are actually the water champions, but they are neglected from any decision making related to water. And National Water Policy outlines the importance of community-based water management, which needs to be institutionalized and strengthened, and women have a key role to play in this. And the fourth point is on sanitation. And for this, I think mass community sensitization is required, and especially among women, because they are the key sufferers. In all the meetings where I go, wherever the women panchayat members and women heads, leaders are there, they are very passionate about having, safe toilet in their premises, which is, again, even in spite of Swachh Bharat Abhiyan, this is something, which is neglected. So these are the 4 points I wanted to flag. And just a couple of takeaways and lessons, because this panel discussion is also on lessons learned. One is, of course, mass sensitization, because as National Water Policy realizes that low consciousness about scarcity and economic value of water is there, because water is so highly subsidized and it provides very little incentive to be used for efficient use of water. So we need government initiatives and community sensitization, which have to go hand in hand. Second is, of course, since we are talking of technology, the importance of hydrological data through GIS mapping is important, both for impact assessment and for assessment of water. And third is the democratic processes, I think, are very important, which involve transparency, accountability, and decisive participation of people on the ground. And we need more civil engineers. We need more technical aspects, more technical engineers, geologists, water experts who can work on this issue. And in the end, I would just like to end by mentioning the 3 C's. One is, I think the whole process should be community-led. The first C is on community-led, because partnerships with communities, especially in rural areas, is the key for any kind of water management program. The second C is commitment and dedication, because this is, of course, a long drawn process. It is not something which can happen overnight. So a persistent commitment is required at all levels, private sector, government sector, community. It has to be like, in partnership. And the third is the competence. The third C is the competence. The skills which are required, as I mentioned, we need more water experts, more skill set, even women who are, skilled as a para volunteers at the village level. They need some kind of skills and sensitization. And of course, the expertise. We need people who can mobilize mass communities, people at the policy level who can work with the government. So community-led, commitment, and competence. So this is how I would like to just end. I know the time is short, so I would not like to share anything more. Thank you so much.
Thank you, madam. Thanks a lot for sharing your the key issues related to achieving the SDG 6. Thanks a lot. We'll come back to you later for the discussion. Now I invite Mr. Jeevan Raj, provide your views.
Yeah, very good evening to all. I hope I'll get time to present. I have made a small presentation. Quickly, I'll run through that if you allow.
Yeah, sure. Please go ahead.
Yeah.
Yeah.
Can I share my screen?
Not yet.
Yeah.
Yes, it's loading now. Yes, we can see the slide.
Yeah. So yeah. Good evening to all. Here, I would like to touch upon the wastewater management. Okay. So how wastewater management affects improper wastewater management affects the groundwater quality and groundwater depletion. Quickly, I'll tell my views and my experience and the challenges we are facing in this field. We are actually a company based out of Bangalore, and we operate pan India the water and wastewater management facilities. So our experience, I'll share our experience in this field. I think the keynote speaker, Mr. Tarun, is also there. We work together in Bangalore to do more technological advantages in the wastewater management and the improvements which can bring the condition of the groundwater all over the world. So here I'll touch upon the main key points which we learned in past. Total generation of sewage in India is very high. Basically, we are concentrating on the urban population statistics. The max says the sewage generation is so high, whereas the installed capacity of the sewage treatment plants, the facilities are at least less than 50% of that. And we know that all the states like Maharashtra, Uttar Pradesh, and the high population states generating more quantity of wastewater. And then currently, what are the available technologies in percentage? Then what are the societal challenges and lessons we learned, and what are the technologies we are applying from our offerings which we are applying towards sustainability. So here it is a very quick figure. So as of 2020 September.
Sorry, Mr. Jeevan, the slide is not moving here. Still, we are seeing the first slide.
I think I'm in the third slide now.
The slide is not in presentation mode.
Okay, fine. So I'll just okay, fine. So total sewage generated in India as per CPCB, Central Pollution Control Board, is almost 72,368 million liters, and the installed capacity of the wastewater treatment plant is only less than 50,000 million liters of capacity, which clearly says that the balance of the water, either it is sending outside or to a public lake or any public other water bodies without treating, which affects the complete groundwater quality all over the country. Second is even the installed capacity of these plants are not in operational condition. Many of the, like if 50,000 MLD of capacity of the plant installed in the country, only 60 to 70% of this capacity is in the operational condition, and in that also only 60 or 70% is giving the treated water to the government compliance. So this actually leads to a big challenge where these all untreated sewage or untreated paid effluents, which the industries or the residential apartments sending outside, is completely contaminating the groundwater qualities. Second, the main point is, if you are not treating and reusing this water, again you need to take the groundwater, and the groundwater levels are going down. Okay, so we as a wastewater management company, we work towards the technologies to improve this. So we are actually we have introduced 3 to 4 technologies, which I'll just quickly tell. One is the safe and green technologies, safe and green methods to treat the wastewater. Okay, we have introduced industry first dissolved oxygen sensors and VFD based solutions to bring down the electrical usage, so that it gives less carbon footprint. Second is we have installed eco-friendly sludge handling units, so which also using zero electricity, plus it gives again less carbon footprint. Third is actually the most important thing is now the Central Pollution Control Board and State Pollution Control Boards are going to monitor all the STPs in the country by 2025. Individual STPs, decentralized STPs, they want to connect to their server. So we have introduced online real-time monitoring of these STPs, which gives the real-time values, the treatment quality of the water. So government agencies can real-time monitor these parameters, the performance of the plant, and ensure that these plants are working perfectly within the prescribed limits. So this will give the increased plant efficiency by continuous monitoring, reduction in the dependence of the human labor. And the third one is actually we are working with a university in Switzerland for the complete automation of these waste treatment plants, because the human makes always error. The human tendency is to make the error. Reduction in errors caused by humans. That is the main agenda of going for complete automation of the STPs and the increased operational life of the STP. When we are actually developing the robots, okay, we are actually in the very initial discussion with the University of Switzerland to develop these robots. By 2030, we want to operate all these plants with robots which can give a high efficiency of the sewage treatment plants and effluent treatment plants, which directly gives a good performance of your groundwater. Then predictive failures of the equipments also can be addressed by introducing these technologies. So we will be more concentrating on the technologies to come into the wastewater treatment, so that wastewater treatment can be improved, so which will be giving a high possibility of recycling the water and saving the groundwater. So it will give two advantages. It will not contaminate the groundwater if you are treating it properly. Second, it will give groundwater to draw less groundwater. So these are the two major advantages by improving the operational conditions of the wastewater treatment plant. So this is what I just want to emphasize from my side. So I will be talking later after the.
Okay, thank you, Dr. Jeevan, for your key points about technological opportunities in achieving this sustained development goal in water. We will get back to you later. So now I will invite our third panelist, Dr. Dakshinamurthy Ramu, for providing his initial thoughts about for our panel discussion. Thank you.
A very good evening to everyone. Thank you for the floor. Thanks for the opportunity, first of all, to speak about a very important thing, water and sustainable development goals. Basically, we all know that water is a complex because it's linked in almost everything in the world. But we need to realize one thing, that water is not an commodity thing. Because we have been covered with 2/3 of part of our planet have been covered with water, and even our body as well as. So what we actually think is water is going somewhere. So, but the global reality is water exists everywhere, but the thing is we can't able to use it. So obviously we know that 2/3 of our planet have been covered with water. But the fact is we can't able to use, because 97% of water was salt and 3% was already frozen. So we can only use 0.02% of water which can be used in a domestic use for drinking and other purposes. So the fact is, the thing is, what we need to analyze is whether we are utilizing these very small amount of water in a fruitful way or not. When we discuss about SDGs with water, so we need to interlink almost all the 17 SDGs with water, because water it's visible, which is invisible, so which is related to all other SDGs. So water have large of matters to think, and there is a lot of things to discuss when it comes to water and SDGs. So we need to think about climate change, we need to think about disaster, we need to think about ecosystem financing and human rights, scarcity, even water, wastewater due to the quality thing and transponder, and all of the things are there. So the main thing we need to, because if I want to speak about a global perspective, it will go in a very big way. So I wanted to control myself into India. So basically, India is a very big country where we have which we have been mentioned in other countries, like India has 7 rivers, but before we had 700 plus rivers which have been interconnected everywhere. But in the last 40 years, we have lost around 60% of rivers in due to natural and man-made disasters. So which make our rich soil as a simple sand. So that's the fact. And also we need to note one thing. So our most of the rivers are based on the forest beds. So we are generating water through the forest. So unluckily, due to urbanization, we have lost all the forest, and we have been moving to the urbanization. In the name of urbanization, we have closed all the rivers and all the things. So there was a less chance of saving the water, which is very which is going to be a drinkable one. So the thing is, when it comes to SDGs, so we need to analyze one thing. So this forest fed are 96%. If we can join together in a mass level with an economic plan, so we can include the farmers into that. If we can create a small forest as much as we can improve this groundwater level. So that's the case. So we need to insist the policymakers to create new forest when it comes to when it comes to drinkable waters. So other than that, we have a lot of challenges we are facing. So lesson learned, we have a lot of lesson learned personally in all the perspective. We can see many villages have been migrated to another village because of this water scarcity. So still it's happening in our India. In many villages, people are trying to migrate only just because of this water scarcity. So that's our we need to keep that thing as an key point, and we need to generate a new policy to make these people to migrate to their same places with inclusively with the waters. And unfortunately, we have a lot of people who is living in a place where they can't get an healthy and nutritious water everywhere. And surprisingly, there was another fact also. So in India, so every year we are increasing. Every year we are increased in the level of people who is suffering without any clean and clean water. So in 2050, we are expecting around 33% of people in India alone, they are not going to get enough water to drink. So we need to act now with the innovation technologies, with the technological opportunities. So we need to come up with an innovation plan. So that will move things better. So this is my initial presentation. So let's move on to next. Thank you. Thank you for that.
Okay. Thank you, sir. Thank you very much for touching in different points. We'll get back to you later. So once all the panelists gives their views, we'll come back to you for the discussion. Thank you. So attendees also can send your questions using the Q&A. And now we we can move on to Dr. Sanjay Paul for his initial points for the 15th.
Thank you,
Dr.
Dr.
Sanjay Paul,
Sundarajan.
yes.
Yeah, thank you, Dr. Sundarajan. Good evening, everybody, or good afternoon, many of you probably different time zone. I'm sharing my screen. I hope you can see that. Can you see my screen?
Yes, sir, you can see
coming probably, right?
slides.
Yeah, yeah.
Yes,
Okay, so this is our topic. So I'll try to showcase our technology, and I'm from water sanitation background. So I'll briefly present our ideas, how we tackle with that and what we have learned, and what are the opportunities lying as a scientist, as a technologist, what we are thinking along this line. And a lot of points throughout the day have been discussed, and right now also rightly quite a few points. I will just focus on the water related to sanitation issues, particularly wastewater treatment. So many of you have agreed or presented in the morning earlier sessions, the nature-based solutions, ecological engineering is the key to the prevention of organic pollution, and the two key parameters, infections and smell, are the two key parameters which are required in treatment and reuse adoption. And the problems are universal. One common notion we see very often that this is primarily developing nations' problem. It's not. Even in developed countries, particularly with respect to recent rise in antimicrobial resistance, we propose that actually the centralized treatment system needs to be really reconsidered, modified, or even to the extent dismantled completely to have proper decentralized solutions. Because centralized systems, there are literature coming up showing that they are the creator or the breeding ground of antimicrobial resistance. So there are a lot of discussion going on. Antimicrobial resistance, the next or not next, as an ongoing pandemic, something it might take a toll of more than our current pandemic has done. So keeping that in view, we have actually, thanks to our funding agencies, we have brought up a lot of science element, being a scientist primarily, science element to the whole treatment process. At the core of the biological wastewater treatment. Basically, we have a lot of biology into it and see how if we can integrate in the technology. So microbial consortium, biological control by bacteriophages, some of the enzymes even, or peptides and small molecules. I'm sorry, okay, now probably you can see. Yeah. So the broad point is that grow good microbes and plant, and then can you bring ecological values, aesthetic values, economic values. We are looking into developing animal feed for the waste. We are looking into methane reduction or carbon sequestration aspect in the whole technology paradigm. And these are some of the data we have successfully shown that we all in a single day retention time, 1 day, 24 hours retention time, we can reduce the coliform count or all the parameters required. We have scaled it up for the household sector. We are looking for actually highly decentralized system at the household level. So this is a system where we have demonstrated at the 500 liter per day sewage tank through a phytoremediation and different combinations of treatment methodologies. And it's very, very aspirational. And then these are a lot of science has gone into a lot of students, manpower, I would say, or rather women power, I generally say. Let me see if I can bring this bottom. Yeah, a lot of last 8 years, I would say, a lot of things have happened, a lot of innovations have brought in, but ultimately my slides are stuck. I don't know. Okay. Okay, it has come. funding agency has poured a lot of money and a lot of collaborations we have built up. And but I'll tell you our test in recent deployment in near Calcutta, our students, I also visited just a few months back, which is at the almost heart of the Calcutta. It's just 20-minute drive from Kolkata. And it's a prime, the small village is surrounded by ponds all along. And you can see the state of affairs, that the water everywhere and not a drop to drink. But when we ask the villagers, they're happy with this water. They are asking for, we need jobs, we need money. We are not worried too much about this dirty water. They are doing fishing with those waters. Productivity might not be that high. We had actually integrated technology to push for developing fish feed, developing other utilities other than irrigation. These are the state of affairs. So they don't require this. They are looking for something very quickly. They can get jobs or some quick values. The groundwater pollution or surface water pollution, they're not bothered, even though they are very much aware of those, but that's not their priority. So we have brought in several technologies at different socioeconomic strata. For example, here there's a garden toilet, we call it. We want to deploy where space is not a constant, the rural where simple filtration bed will take, and that will be used for irrigation water. So probably we have to scale down our from the black water to gray water reuse, and then looking for economic value immediately. So kitchen garden is something we are thinking about. So this is something we have demonstrated here in our campus itself, that you can create actually almost a forest. The forest creation Dr. Ramo has pointed out, that's one of the most fruitful of groundwater recharging fruitfully. In fact, all pollutions have forest creation is one of the major solutions we can think about, and everybody is talking about it. But our villagers or the bottom of the pyramid, we basically need to kind of, my point is, need to serve them with adapting those technologies. On the other end of that, end of the pyramid, I'll tell you another story, just recent one. We proposed to this vertical garden concept to HDFC to spend their CSR fund, and they readily accepted. We proposed them that why don't you use the community toilets and other spaces as a green advertisement tools, and they readily agreed, and they have funded us, and we'll be implementing that in Delhi. So there our technology is very good, very apt, whereas in the rural, what I say, bottom of the pyramid, we really need to work a lot with respect to not only technology, but the socio-economic acceptance of it. This is another aspect we propose to the HDFC. So hopefully in a few months, we should be able to deploy in the community. We don't know what is in store, but that's what we are hoping for. Thank you very much.
Thank you, Dr. Sanjay Paul, for your wonderful presentation as well. We'll come back to you later, sir, after discussing with all the panelists. Now I will invite Dr. Vishwanathan, sir, for giving his initial points about SDG 6. Thank you.
And thank you. Am I audible to you?
Yes, sir.
Okay, so thank you, Mr. Chair, Dr. Soundararajan, and the distinguished panelists. In fact, I wanted to talk mostly on the governance aspect, water governance aspect. I'll be talking about 3 points in this regard. Of course, we know that Sustainable Development Goals with respect to water or SDGs, if you wanted to look at SDGs or relate water with the Sustainable Development Goal, almost all the goals can be related to SDGs one way or the other. So I start with that kind of a basic assumption or basic proposition. So when we look at the groundwater development scenario of India, I wanted to take you to little about the history of development of irrigation systems, where we see a greater paradox in the sense that now since independence or since the planning era, we have given major focus on development of surface irrigation systems or major irrigation systems or mega river valley irrigation projects, etc., etc. And a lot of government investment, public investment also went into development of canal irrigation system. But the paradox was that when the public investments went into development of canal irrigation systems or surface irrigation system, farmers actually took a totally different turn altogether. They started investing in terms of, in public, in their own water sources, like started with open wells. Then later it went on to the development of tube wells. And there was also a period of tube well capitalism, which was actually reigning the entire water sector of India. If you look at the literature during that period, 1970s, 80s and all, or even 90s also to a larger extent, a lot of debate was going on the expansion of tube wells and also the promotion of tube well capitalism. And it was, again, I would say that a lot of public policy also, public support system was also very much aligned towards promotion of groundwater economy in India, because or later we started talking about these subsidies or these government support systems as environmentally damaging kind of subsidies or support systems and all, which has turned out to be quite damaging with respect to the groundwater extraction. You will see that the negative aspects of groundwater development, particularly starting very much confined to the initially confined to the groundwater, the green revolution areas of Punjab, Uttar Pradesh, Haryana, to a larger extent again, also into the northern, western states of Gujarat, Maharashtra, Rajasthan, etc., etc. And again, you can see that the level of development of irrigation systems was mostly triggered by groundwater tube well intensive irrigation technology. That's the first point. Second point, I wanted to talk about the policy interventions that came, particularly in 1987. And actually, it aligned with the idea of or the understanding about the challenges that has been posed by climate change on the first hand, and also the development of the concept of sustainable development. And in order to align those kind of the global challenges or emanating from climate change on the one side, and also the requirement for sustainable development, India also has launched what is known as a national water policy in 1987, which was continued later. We also had the 2000 another second water policy. And what was the importance of second water policy in 2000 was that most of the states also came up with their own individual state water policies. And if you very carefully look at the state water policies, it is basically a copy and paste kind of a water policy, which again followed the national water policy and just copied and pasted the objectives or the broader perspectives in which the entire water policy has been designed. And again, one of the important aspects of this water policy was prioritization of water allocation. Firstly, most of the states have given first a priority for drinking water, followed by irrigation, then industrial water use, commercial water use, and finally the ecosystem requirement also came up in a very bigger way in the context of climate change. But again, if you look at the kind of prioritization that has been given to ecosystem services in the water policies, it has assumed maybe 6th or 7th position in terms of prioritizing water policy. Then that leads to me to talk about the third point, which is the last point, which I wanted to talk about, is about the water governance scenario. We need a paradigm shift in the water governance, because why I say that we need a paradigm shift in the sense that we all are actually considering the water governance basically driven by three major institutions. For instance, the Central Groundwater Board agencies, basically not institution, Central Groundwater Board, the Central Water Commission, and the Ministry of Water Resources Development. These are the three major agencies which have been actually quite actively involved in the development as well as governance of water resources. But if you look very carefully, look at the kind of activity that particularly Central Groundwater Board or the Central Water Commission, they have been basically collecting a lot of data, or maybe their involvement was not so much with respect to the ground level, understanding the ground level realities, and also trying to understand, also make a lot of interventions at that point. It was never actually been happening. On the other hand, if you look at the other kind of a development, which was actually triggered by the Ministry of Water Resources Development, they have given more importance for canal irrigation systems, and they also never looked at the groundwater governance as a major point of action to be undertaken. So, because of all these three important aspects, I would actually argue for a very important change that is required, a paradigm shift required in the context of water governance, mainly because of the redundancy factor. The redundancy factor is because of the failure of the three agencies in terms of implementing water governance in the appropriate way or in the appropriate manner. So when I talk about the institutional redundancy, I would actually talk about the technological kind of opportunities or technological challenges also. The opportunities, I don't know whether it's an opportunity or a challenge, particularly if you talk about the institutional intervention that came along with the micro irrigation system or under the National Mission on Micro Irrigation. It has been promoted by the national government as well as it was also implemented by the respective state government under the various schemes, under the various kind of promotion tags like Har Khet Ko Pani or more crop per drop. These were the two important slogans that have been promoted in order to implement the micro irrigation system. And please also remember that the micro irrigation systems have been promoted by all the state governments under the central government's initiative, with a lot of subsidy given to the farmers. And again, there is a total turnaround in the subsidy paradigm. Now we are actually started giving environmentally kind of sustaining kind of a technologies. Quite a contradicting situation compared to the earlier scenario where we were promoting irrigation technologies or tubular technologies by giving a lot of environmentally damaging subsidies. Now we are actually reversing the kind of subsidy regime in the latest scenario. But then I would say that the technological intervention, though it has been promoting micro irrigation adoption in many states, the largest adopters are the states where larger farmers or medium farmers are very much there, concentrated there. It's actually not benefiting in a larger way in terms of supporting the small and marginal farmers of India. So there is a kind of huge inequality is actually emerging in the context of technology promotion in the form of micro irrigation system. And what happened? Of course, the technology intervention micro irrigation system is supported to be beneficial in terms of water saving on the one hand, secondly, energy saving also. These two things are, I don't know whether we have achieved it. Yeah.
Excuse me, sir, can you stop it in another?
Yeah, I'm just finishing in 1 minute. So the point here is that instead of helping to achieve the social objective or the sustainability objective of developing this technology and promoting for the benefit of the intergenerational equity of resource transfer and all, this technology also has miserably failed. So on all these important parameters, I would definitely argue for revamping of the water governance scenario in the years to come. Otherwise, the water security or water future of India is going to be in a serious situation. With that, I just wanted to conclude my initial thoughts on the subject. Thank you.
Okay. Thank you, sir. Thank you for your initial thoughts. We also hear from Dr. George already. So now we are directly moving to the discussion part. And now we start with Miss Anjali. So there is a question from the audience, as well as we have another question as well here. So the question is about, so you mentioned about 3 C's essential to manage water. So I feel convergence is also equally important, as this brings the resource envelope to develop the assets required to sustain the sources. So this is a question from audience. Could you
Yes.
respond to that question? Yeah.
Yes, I totally agree. Convergence, or as I had mentioned, synergy is very, very important. And at all levels with the community, as I say, one of the SDGs is on partnership, one of the sustainable development goals. And I think that is the goal which talks about synergy and convergence. And we have just heard about water governance. So at the policy level, at the government level, at the community level, at the demand level, at the supply level, as well as the private and the public sector, both not only researchers, but CSR partners, the private sectors, the civil society organizations. I think there is a lot of convergence required, and amongst different ministries also. We have Ministry of Jal Shakti, we have Ministry of we have another ministry dealing with agriculture, then another one on climate change. So a lot of convergence at the different ministries level, and it has to be on a partnership mode. So I totally agree. It's good to add the 4 C's. So instead of 3 C's, yes, the 4th C is very relevant. Thank you.
Yeah. Thank you, ma'am. And we have one more question as well. Can you give any example for lessons learned so far in achieving the SDGs in water, especially from Indian context?
Yes, there are a lot of lessons, especially I think one thing is water is, as Dr. Vishwanathan had also mentioned, that it's subsidized. So the sensitization of the scarcity of water as a commodity is not there in the rural areas. So for them, it's a subsidized commodity which is freely available. And as you increase the supply of water through water harvesting, there we see that there is a change in cropping patterns. So instead of crop practices which use less water, they start using crops which are using more water because water availability is there. So I think one major lesson is that we have to work both on the supply and the demand side. And from the demand side, extensive community mobilization and community sensitization of women especially is very, very important. Women and men. Women for taking part in the decision making, and men because they influence the decisions. So I think it is very important. And the second lesson, I think, when we are talking about sanitation and importance of Swachh Bharat Mission and latrines, I think what my experiences has been, earlier we used to go to the panchayats, and panchayats sometimes are headed by people who are not so, toilet is not a priority for them. But when we develop women leaders, then for them there is this priority of latrines, because they have to go out, and open defecation is something which they want to really avoid. So mobilizing women on open defecation free village, I think that is that is the key. And India has a lot of water. And the third lesson is, of course, to work very closely with the government, because government has the potential to scale up. So we can, of course, have structures, and we can have technologies, we can have demonstrations, but to sustain these, even if we have built a check dam, it has to be maintained over a period of time. So the government, I think it's very important. It's a key stakeholder, and it's important to work with the government. Yeah.
Thank you, ma'am. Thanks a lot. And then now I move on to Mr. Jeevan. So Jeevan, you mentioned many technological advancements which can help in achieving the sustainable development goal in water. Could you tell us how fast and what scale we can able to deploy them? And is there any issues in scaling up the technologies and innovations we make in wastewater treatment, and how easy they are even deploying in the rural areas? Because the rural areas only they need the most. Could you give your views on that?
Yeah. See, the wastewater management and even water management is very, very important both in urban and rural areas. Okay, see now the urban areas really they have gone out of control now. The urban areas are really having big challenge on the water management. Okay, they are even I lives in the city of Bangalore, so where we have to dig 1,300 to 1,500 square feet feet down to get a single drop of water. So the condition is getting very, very worst here. Rural areas still we have the water resources are still good, not so bad. But coming back to the point, how the technology is going to play a major role both in urban wastewater and water management and also in the rural areas. So if you see that last 2 years or 3 years data, there are a lot of IoT based solutions came into the water and wastewater management. In that, very, very important is actually we use an IoT solution where we have all the controls of the water quantities as well as the water quality monitoring real time. So what we get, okay, CPCB and CPCB National Green Tribunal plus the state pollution control boards made it very mandatory that all the STPs, either it is centralized or decentralized, they should go for two things. One is actually you should have a inlet measurement, like inlet flow meter to measure the inflow of the water, influent of the water, the quantity of the influent. Similarly, you should have an outlet meter to measure how much water you treated. Okay, this will give a balance. So this will be, once this connected to the server of the Central Pollution Control Board or the State Pollution Control Board, what happens? They will not allow you to cross more than 5 or 6% of variation. If you get 100 liters of water in the inlet, you should treat above 95% of the water which you received. So this actually force the individual properties or the centralized or decentralized plans to do more effective or effective treatment of these wastewater treatment systems. Second point is the IoT based solutions really help in understanding your parameters. So mainly as Dr. Sanjay sir said, the parameters, okay, the biological treatment, how effective is your biological treatment. Most of the sewage treatment plants in the country works on biological process. So how effective this biological process, we have now the IoT based solutions are available. We have sensors to measure BOD and COD with the turbidity sensors. Our eminent professors and our institutes like IIT Madras and IIT Roorkee, they all developed these kind of technologies, and it is widely using in India from past 2 to 3 years. So this actually, we are operating around 100 plus wastewater treatment facilities in the city of Bangalore and pan India, many places. So we have seen a visible change in the efficiency of the wastewater treatment plant and how the industries can reuse this water and how industries can take benefit of protecting their groundwater. Okay, by reusing this water, I have seen that many industries we have brought from the negative water balancing to a positive water balancing. So now people have excess water and people are now searching for the buyers. Okay, in the city of Bangalore, we have lot of residential apartments having almost 50% of the treated water. They don't know how to use it. So these technologies are going to play a vital role. Similarly, I am talking about the urban area. Similarly, now if you look at the rural areas, the rural water management is having the IoT based sensors to measure the quantity of the water the individual houses using every day. So this will have all the control of the non-revenue water. Okay, because even for identifying the leakage. So there are technologies now widely in Bangalore Water Supply and Sewerage Board is using these technologies to identify the leakage of the water, and million liters of the water can be saved by adopting these technologies. And now I'll take 1 or 2 minutes maximum. Now the wastewater treatment management is actually a very tough job. Okay, the major challenge is we don't get the proper trained manpower. Okay, so one thing now we are doing is we have signed an MOU with the Skill Development Center of State of Karnataka to train the people from the urban and rural areas how to manage, how to operate the wastewater treatment facilities for a better result, better output. So that we are already signed an MOU. Second is because of these human errors, the plants are actually going into a very bad condition. So now the technology, why the technology is going to play a vital role here. Many of the multinational wastewater treatment operating companies are coming up with the AI-based, artificial intelligence-based operations of the plant, which gives you 100% perfect operations. It can be a predictive failure. It can the predictive failures can be attended much early, and it can be avoided. And this will actually reduce the downtime of the plants and give you the more efficiency. So this technology is actually having a big role. So we are even a step ahead. We are already discussing with the universities to develop the robot, humanoid robot to operate these plants. So that the main aspect is the safety aspect of the human, because of as Dr. Sanjay said, the methane gases generates inside the plant. Okay, there are a lot of people dies because of that, and their living is getting very difficult. So we are developing the robots to operate the plant. So these are the technologies actually we are looking at to improve the treatment facilities, and that is actually directly will contribute to the groundwater improvements, groundwater quality improvements, then groundwater levels, okay, quantities, qualities, in all ways. This is what I can like. This is our experience, because we are operating around 100+ plants, and we are experienced how difficult it is with hands-on experience. From this experience, I am sharing this.
Okay. Yeah. Okay. Thank you, Jeevan, for your great explanation. Now I move on to Dr. Georgie for his views on how ecosystem services can provide, or what can provide to the SDG 6. Because one of the objectives, if you look at one of the targets, if you see, is integrated water management, which also includes ecosystem services. So what challenges we have in integrating ecosystem services within integrated water management, which will lead us to, or will take us to SDG, or achieving the sustainable development goal in water. Over to you, Dr. George.
Very nice meeting you all, and thank you very much for the question. It's very interesting in the sense that I mean, ecosystem services are very important, right? For for human beings. I mean, we rely on the benefits, the services, the goods and the services that nature provides for our livelihoods. And I think, I mean, I like through the panel, I heard very interesting aspects, and I think they are like totally interlinked. For instance, I think we do need to understand, first of all, like how ecosystem works, like how everything is integrated. I mean, like surface water, how it's integrated with groundwater, and how that relates to land, to like vegetation and the atmosphere, and the whole cycle, right? How every component of the ecosystem works, and why they are important. I mean, we have a general idea, if we want to say, like, but like for specific places, I think it would be important to know that, because that would like determine how we would manage the ecosystem, and also determine what ecosystem services we can obtain from the ecosystem. So I think that's the main challenge. The scientific knowledge kind of knows in general how things work, how how things should function and what things should be done, what things can't be done, or so. But then, I mean, I think local knowledge also does that thing to some extent, or in a different way, I want to say. So I think it is important to integrate in both knowledges, and from that, know what is important for human beings and for the ecosystem. Because as I said earlier, I mean, if we don't maintain the ecosystem, we won't be able to get these ecosystem services. So understanding like the benefits that nature gives us, I think is very important, and also providing a value, right? I don't think we can just say like, yeah, nature gives us water and that's it, right? We need to measure things. I mean, we need to measure how much water is giving us, and how much actually that costs, and how much we will lose if we affect that water by some human activities. For instance, how much it costs to treat water, for instance, right? Or how many fisheries we're losing, how many pounds or tons or of fisheries we're losing because of contamination. So I think it seems like simple to think about that, but it's difficult to see that at bigger scales. I mean, and integrate everything at a larger scale. So I think also like thinking of how we are organized among populations, it seems to me that it's easier to work like very local scales, and also because higher scales, I mean, of government, for instance, there's a lot of politics and a lot of bureaucracy, and sometimes like there are like regulations are so too stringent, and or like they're not like kind of too thoughtful, if you want to say. So I think it is important to have some things to guide us, right? But then from the bottom up, start like working up and actually improve management. So maybe working at a small scale, like a catchment kind of thing, or like a small water board or so. It would facilitate the implementation of some of these. First of all, like the assessment of ecosystem services and the implementation of activities that would allow us to maintain these. And then it would like, I mean, like I love some of the ideas, some of the actually experiments that some of you are conducting, for like to improve management, like nature-based solutions, for instance. I think like starting at the household level and then working at the community level and then going up to higher levels of the society, it seems like the most feasible thing to me. And of course, like having some, as I said before, some instructions, right, or some directions, guidelines from above. Although also like at that level, I think it is very important to work, and I would say above levels, very important to work on capacity building and education, because I mean, people don't understand how the water cycle works. I mean, someone was telling me yesterday in an interview, like water is used for like humans, then for agricultural, industry, and then the rest is wasted. So it's not wasted, that water. That water goes into the ecosystem, and that is going back towards us, right? So I think training people at all levels of the society, it would be very important to facilitate all the partnerships, to facilitate like the implementation, the management practices, and eventually improve quality of life. I think, yeah, I guess that's what so to end, I would say that we cannot think of water security or like food security even if we don't think of ecosystem security. I mean, the ecosystem has to be properly working to be able to provide us all of the ecosystem services that we need. Yeah. Thank you. you very much.
Thank you very much, Dr. George. Yeah, thanks a lot for giving you the comprehensive view of ecosystem services. What are the challenges associated with it? It's really difficult to even comprehensively understand the system itself. Thank you for providing the nice discussion. Next, we move on to one more question and then we can wind up, I think. Next, we can move on to Dr. Dakshinamurthy Ramu. And you mentioned that we can increase the forest cover with the participation of farmers. I don't know whether I understood that one correct or not. Doctor.
Yes. Actually, the one best part is so most of the rivers, the places nearby the rivers have been reserved by the government of India. So my statement was building small forest along by sides of the rivers. So basically, we need the like local community to get involved in mass level to create a real change in the society. So for that, we can include inclusively the farmers who is working in their field. So like subconsciously these people can be used with a proper economic plan, because since most of our farmers are a bit poor in the basis of economics. So when we can involve these farmers with a proper economic plan, even we can utilize their own land for building tree-based farming. So these tree-based farming will balance them in economic as well as a climatic action ways. So probably there are many tree-based farming which have been already shown that which lead them to gain their income up to 3 to 4 times. So when we have a proper economic plan, when we have a mass inclusion along with the belts of rivers, we can build a tree-based forest farming, and also we can utilize the government lands which is nearby the rivers. So these tree-based forest farming will lead to generate a proper groundwater level, which can be utilized for the future purposes. So that's my point. So thanks for the questions.
Thank you. This is really new for us as well. We haven't thought about it in the past. So it looks promising as well, and also will generate revenue for the farmers probably in the long run. Thank you for giving all the points. So already we have heard from Dr. Sanjay Paul as well as Dr. Viswanathan sir in detail. So with this lack of time, we have to close the panel discussion. Thanks a lot for all the distinguished panelists for providing our views about achieving sustainable development goal in water, especially in lessons learned from Ms. Anjali, as well as challenges and then technologies from Mr. Jeevan, as well as Dr. Dakshinamurthy. And Sanjay Paul sir, as well as Viswanathan sir, also provided possible technological interventions as well as societal challenges from their end. And as our Dr. Georgie mentioned, it is easier said than done, because you can see a lot of complexities when it comes to when we are talking about SDG 6, where many times we are touching other SDGs, like we have to talk about irrigation, we have to talk about food, we have to talk about other aspects. So it's really a very, it's a kind of very complex stuff. And then achieving this also, it's very difficult thing. So I hope we can able to achieve this reasonable level of sustainable development goal in 6 by 2030. But thank you all the thank you all the panelists for your wonderful time, as well as giving all your knowledge, sharing your knowledge with us. Thank you all the attendees for your time and staying us with us. Even it's very late for you as well. Thank you all the organizers providing all the
Thank you.
facilities. Thanks a lot.
Thank you so much.
Thank you. Thank you.
Yeah,
Thank you so
very
much. Thank you very much for
Thank you,
inviting us
everyone.
for this
Yeah.
discussion. Thank you very
Thank you
much.
very much. Very nice meeting you all.
Thank you. Thank you. So attendees, we can meet tomorrow as well to the same time, 4 p.m. It starts our third event is starting at 4 p.m. tomorrow. Thank you all. Good night.
Good night. Bye. Bye.
Thank you.
Thank you, Dr. Soundarajan. That was indeed an illuminating second day to the International Symposium on Water Sustainability, IWSS 2022. Our heartfelt gratitude to all the speakers and attendees. And we request all of you to please fill out the feedback form posted in the chat. And we would love to see you all back for the final day of the symposium at 4 p.m. IST tomorrow. Great day. Thank you.